Day 1, Introduction to Python and Development Setup. Let's jump into overview of Python and its role in AI. Now, why Python for AI? Python has become the go-to language for AI due to its simplicity, readability, extensive libraries, and supportive community. Libraries like NumPy, Pandas, TensorFlow, PyTorch, and scikit-learn make Python ideal for machine learning and data analysis. Now let's look at some of the applications of Python in AI. Python is widely used in various AI applications such as machine learning. Libraries like scikit-learn enable building and deploying ML models. We have deep learning, where we have TensorFlow and PyTorch, which power neural networks and deep learning architectures. In data science and analytics, libraries like Pandas and Matplotlib allow data manipulation and visualization. We also have natural language processing or NLP. We have NLTK, Spacey, and transformers, which are the key for language related tasks, and automation and scripting. Python's simplicity and flexibility make it perfect for automating repetitive tasks. Next, let's jump into installing Python and setting up a coding environment. Here, first, we'll be installing Python. We'll be visiting python.org and download the latest version of Python for Mac. And then we're going to do the similar thing in Windows. We're going to ensure that you check your options to add Python to path during installation if you don't have it. But in my case, I will have directly set up available. But if you have any issues, let me know. And then we're going to go to setting up a coding environment. We'll install Jupyter Notebooks, which is a popular tool for interactive coding, ideal for data exploration and visualization. We'll be installing that by running pip install Jupyter in the terminal. Now we're going to do that in Mac, but on Windows, it's the exact same command. And then we will start the Jupyter Notebook by running the Jupyter Notebook in the terminal to open the notebook interface. Next, we're going to go ahead and install Visual Studio Code. We'll be downloading it and installing this from code.visualstudio.com. And then we're going to install some Python extension, which in VS Code is used for syntax highlighting, autocomplete, and debugging. We'll be doing configuration of Python interpreter, where we set the interpreter to the installed Python version for easy script execution. So let's go ahead and install Python and set up our coding environment. So first step is to install Python. So I'm going to go here into python.org, go into downloads, and in here I can download Python 3.13.0. If you want to download Python for Windows, you go here and you download, but there's another way that I'm going to walk you over. So I'm going to, for Mac, I'll go ahead and download Python. It's going to take a few minutes. So I'm going to go to Visual Studio Code, which is code.visualstudio.com, and download my Visual Studio from here. You can do the same thing for Windows and download for Windows. And now it's downloading my Visual Studio. I can open my downloads folder, and as you can see, Python is already downloaded. So I'm going to click on that and walk through this process. Continue, agree, install, put my password in. And it's going to take some time. At the same time, I'm also going to run Visual Studio. And it installed my Visual Studio here. I'm going to bring that and put it on my dock and open Visual Studio Code. And say open, close all these tabs that are open. And first, let's go ahead and see our Python installation. And it says Python 3.13 for Mac OS or later was successfully installed. I'm going to close this and move this installer to trash. Now to check if I have my Python installed, I'm going to open my terminal and say Python, and it should give me an option to write Python script. I'm going to say print hello world. and it prints it out. So that's perfect. So that means I have Python installed. I'm going to do the same step now in Windows. So in Windows, first I'm going to click on the Windows icon and then open command prompt by pressing CMD. Here I'm going to check for Python. If Python is not installed, it's going to take me to Microsoft Store and it will give me an option to download Python here. So I'm going to go ahead and press download, and it's downloading right now. It's not going to take much time to download Python in Windows directly from here. So I'm going to give it a few seconds. This is almost done and installed. So I have it downloaded. I'm going to press launch, and this will launch another terminal, uh, which I will open here, and you see my Python prompt is available here. I can type print hello world, something that I did in Mac, similar to that, and it will print out hello world for me. I can do the same thing in my other terminal where I can write Python and it will give me the Python prompt. So if you're opening something new, you can directly use the Python prompt from your command prompt, and it will let you type your Python code. So I'm going to type quit, or it's actually quit with brackets. I'm going to do that, and you can quit out of Python. Now that we have installed in our Mac and Windows Python, so next step is to get the Jupyter notebooks, which is a popular tool for interactive coding, ideal for data exploration and visualization. So I'm going to say pip install Jupyter, and it's the same command for Windows too if you're installing on Windows. It's going to take a couple of seconds or minutes, and once it's done, it's going to tell me that it's installed all the packages. So I'm going to give it a couple of seconds. And there you go, it's installed. So now I'm going to clear this out and say Jupyter notebook. And it's going to run my Jupyter notebook right here on my browser. And here I can go and create a new notebook here. I'm going to say Python 3. And here is my Jupyter notebook. I can just say print hello world and run it, and you'll see hello world being printed. I can fix this by saying this and run it again, and it will print it out. So I have my Jupyter notebook installed. If you had any issues or problems, let me know. Now let's go back to our Visual Studio editor. So we have our Visual Studio editor installed. First thing that you would want to see is go into extensions and look for Python. So I can just say Python, and it will show me my Python, and it says this is already been installed, but you need to restart this extension. So I'm going to restart this. If your first time coming here, you'll probably see an install option, and just install it from there, and you will have this plugin added to your Visual Studio Code. Next thing that we want to do is set the interpreter to the installed Python version for easy script execution. So for that, I'll make sure my Python extension pack is also installed. And once that is done, you have your Python installed, and you've also set up your coding environment. You can start with running our first projects, which we'll cover in a short while. Introduction to basic Python syntax, variables, and data types. Here, we will look at some of the basic syntax, like how to use comments, where we will be using a hash or a pound key for single line comments and triple quotes for multi-line comments. We'll be looking at indentation. Python uses indentation to define code blocks, unlike other languages that uses braces. Also, we'll look at variables. Variables are dynamically typed, so there's no need to declare types explicitly. We'll look at variables which are defined by assigning values. Example, we'll create a simple variable and assign it some values. And then we'll look at different types of data types. We have integers, which are whole numbers like 1, 42, -3. We have float, which is decimal numbers like 3.14, 2.7. It can be negative, like -1.5. We have strings, which is text enclosed in single or double quotes. And then we're going to talk about lists, which are ordered mutable collection of items. Example, you can have inside square bracket 1, 2, and 3. You can also have strings inside it. Then we're going to look at tuples, which are ordered immutable collections, which we'll look in our examples, how they are different from list. Then we're going to look at dictionaries, which are key value pairs. And then finally, we'll look at some booleans, which are true or false values used in logical operations. So let's go ahead and look at examples of using variables and data types in our code. I have my Visual Studio Code editor available. I'm going to go ahead and say new file. Here we are going to look at different Python variables and data types. So I'm going to say I want to select a Python file. So I have my Python file created. Here first, let's look at integers and floats. Now my font is very small. I'm going to increase it just so it's much more clear. So integers and floats. Now if I want to create an integer, I'm going to create an integer age and give it a value 25. I want to give height as 5.9. Now first one is an integer because it's a whole number, and the second one, height, is a float because it is a decimal point number. Next, we looked at strings. So let's say strings. For strings, what I'm going to do is I am going to use a variable called as name and provide it Alice. Now, every time you provide something inside double quotes, that's what creates a string out of it. I can also create a concatenation string variable. I can say greeting equal to hello and pass that previous variable from above here saying hello name. That's how you can create strings with concatenating each other. So this will greeting variable will have hello Alice in there. Next, let's look at list and tuple. So I'm going to create list and tuple here. Numbers variable which will have 1, 2, 3, and 4. These are the four numbers that I'm going to put inside this particular list. So this is how you define a list. Now this can be numbers and it can also be names array where you can have Alice and Jack inside it, something like this. Now let's look at tuples. So for that, I'm going to create a variable called as coordinates, and to this I will use the rounded bracket and say 10, 20. So this is the tuple which has two values inside it with inside rounded bracket. So that's how we can say it's a tuple. Now let's create a dictionary, which is I mentioned is a key value pair. So a dictionary looks something like this, where I say persons equal to where name is Alice and age is 25. So here I'm saying there's a person whose name is Alice key and this is value, and next key is age and the value is 25. And finally, let's look at booleans. Is underscore student equal to true. So this is how you can create booleans. We can give true or false. These are the different values that boolean variables can have, and we'll be using all these quite a lot in our projects. So let's jump into the next topic, which is hands-on exercises. Next is our hands-on exercise. For our first exercise, we'll be writing a Python script to print a message. So let's get started. So our objective here is to create a simple script that outputs text. So first, I'm going to open my Visual Studio Code. You can do this in Jupyter Notebook too, but I would use this for now. Create a Python file. I'm going to create a folder on my desktop, call it AI Bootcamp, and I'm going to save it inside here. So I'm going to save this. I'll say, where do I want to save? Desktop. Inside my AI Bootcamp, I am going to call it day 1 exercise 1. And here I'll write the code print hello, comma AI world. That's about it. So now I'm going to run the script. To run the script, I'm going to open my terminal or command prompt, depending on which machine you are. And you can just go to desktop, in my case, wherever the file is saved, which is AI Bootcamp. And I see this file here. I'm going to say Python day 1 underscore exercise py. That's what runs the code. And it says hello AI world. Whatever I've written here will be displayed here. So if you got this working, great. If not, let me know. So now that you've completed exercise 1, let's jump into exercise 2, where we will practice creating and manipulating variables of different data types. The objective for our exercise 2 is getting comfortable with variables, data types, and operations in Python. So first, here what we'll do is we'll define variables for an integer, float, string, list, tuple, dictionary, and boolean. So everything that we learned. We'll experiment with basic operations such as concatenating strings. We'll look at adding items to list and accessing dictionary values. So for that, I am going to create another file, Python file. I'm going to save it as day1 exercise2.py. And here, first I will define variables of different data types. So whatever we picked up today. So I'm going to say integer underscore variable. That's the name that I'm giving it. And I'm going to assign it value 10. Okay, there you go. Next, I'm going to say float variable. I'm going to give it value 3.14. Next, I'm going to say string underscore var. And for that, I am going to call it AI. Next, I'll have a list, which is list underscore variable. And here, I'm going to put values 1, 2, and 3. Next, I'll create a tuple underscore var. And to it, I'll put values 4, 5, and 6. Next, dictionary variable. I am going to call it, inside this, I'll have a person with name of Alice, and role of this person is an engineer. And then I'm going to create a boolean variable and set it initially to true. Next, now let's print and manipulate the variables. So I am going to say print and manipulate variables. So first step is printing our integer variable. So I'm going to say integer, comma, pass integer variable. So this will print my integer variable. Next, I'm going to say print float, comma, float variable. Next, I am going to say print. This time I want to display string. So I'm going to say oops, string, and to this string I'll say string variable. Also, I am going to say add bootcamp at the end of it. So I am concatenating here. So it will say whatever the value of string is, which is AI, and then bootcamp at the end of it. Next, I have my list. So to the list variable, I want to add one more item to it before I even print it. So I'm going to say append and add the item 4. So we have 1, 2, 3 in the list, and I want to append another object here called as 4, the number 4. Now if I print this and I call it list, comma, list variable, and see what it displays outside. Next, I want to display the display the tuple. So I'm going to say tuple, comma, tuple variable. Next, we have dictionary. So I am going to say print dictionary value, and here I'm going to say dictionary variable. Now I don't want everything inside it. I just want to display the name. So I can just specify the key. If I don't do specify this, it will show me the entire dictionary, but I just want to see the name. So I can do that. Next, I'm going to say print me boolean. To this, I am going to say bool variable. So let's go ahead and run it on our command prompt here. So I am in the folder. I want to run this one. So I'm going to say Python day1 underscore exercise 2.py. And as you can see, it will display me integer 10, float 3.14, print string AI, and then I concatenated bootcamp, and that's why it's there. My list, which was 1, 2, 3, got appended by 4. That's why I see 4 items here. My tuple has 4, 5, 6. My dictionary value, which is I was specified for name, and it gave me only Alice. If I say role here, it will welcome back. Today on day 2, we will be covering control flow in Python. Control flow is pretty important. So let's get started initially with conditional statements. Conditional statements allow a program to execute specific blocks of code based on the conditions. Let's look at a syntax of what all different things are available in the conditional block. First, we have if, which executes code if a condition is true. We have else if, adds additional conditions after the initial if. And then finally, we have else, which executes code if none of the previous conditions are met. Let's look at a couple of examples for doing this. So I'm going to open my Visual Studio Code. I'm going to create a new file, call it Python file. I'll save it on my desktop AI Bootcamp. I create a new folder, or inside week 1, I'll create a new folder since it's day 2 inside our week 1. And here I am going to save this as day 2 underscore 1.py. And here, let's start with an example. Let's call it example 1, where we are checking a particular condition using control flow. So I'm going to create a number variable and give it a value of 10. Next, I'm going to check if number is greater than 0, which is true in our case. It will say or print positive number. Now, this is a conditional statement where it will check if a variable is greater than 0, which is in this case is, so it's going to print this. But what if I want to check for multiple conditions? So I'm going to say else if number equal to 0. So let's say if the number is 0, then I want to just say print 0. And finally, I'll also add an else, which means if it's not greater than 0 and not equal to 0, then which means it's less than 0, which means it's a negative number. So I'm going to say print negative number. Okay, so there you go. So it's either positive or 0 or a negative number. That's what I'm doing here. I can save this. I'm going to go to my command prompt and see that I am in week 1. I'll move to day 2, clear this. So I have my day 2 underscore 1. I'm going to run this Python day 2 underscore 1 py, and it says positive number. If I change this number to 0, run this again, it will say 0. If I change it to minus, let's say 50, run this, it'll say negative number. So what happens is every time it looks at the number, and depending on which one of these are true, it will print that particular value. Either if it's greater than 0, which is 50, will print positive. If it's 0, it will print 0. And finally, if the number is negative something, which is less than 0, it will print negative number. So let's do another example for this, just to get clarity on this. I'm going to call it example 2, and this one I'll call it nested conditions. So in this case, what I'm going to do is I'm going to set a variable called as age and set it to 25, and I'm going to check if age is greater than 18, and then I'll put a couple of more conditions in there. I'm going to say if age is less than 30, which means the age is in between 19 and less than 30 to 29. So I'm going to say this person is a young adult. And if it's not, else I am going to say print adult. Save this. I'm going to comment this out by putting the hashtag over there. Clear this out. Run this code again, and it says young adult because the age is 25. But what if the age is 32? Run this again, and it says it's adult. So what it does is it checks, first of all, is this person an adult? And I will check if that person is less than 30, then it's young adult, which means the age is in between 19, it's between 18 and 30, so it's 19, 20 up till 29. If it's greater than 29, if it's 30 or above, it will say print adult. But what if it's 5? It's not even going to run into this. So if, let's say if the age is 3, I run this, nothing is printed because it will not even go inside this particular nested conditional statement. So that kind of wraps up our control flow in Python. Let's look at the next thing that we have to do. Next, we have loops. Now, there are different types of loops. We will start with for loop. Now, for loop iterates over a sequence of items. It can be a list that we have seen before. It can be a tuple. And again, it can also loop over string, because string is nothing but a sequence of characters. And we also have range and other things, which we'll look in future. So let's first look at the syntax for this. So if I want to use the same one, comment it out, go above, and I want to look at the syntax for loop, and that goes something like that. You say for item in a particular sequence, be it, as I mentioned, list, tuple, string, range, and or anything else, I can write my code block inside here, something like that. Now let's go ahead and create an example. So what I'm going to do is I am going to comment this out, and let's create an example where I want to loop through a list of items. So to do that, first let's create that list. I'm going to say fruits equal to, I'm going to create a list of fruits. The first item I want to say apple, another one I want to put a banana in there, and C for, let's put cherry. So I have a list of fruits here, and now I want to loop through them. I'm going to say for fruit in fruits. So this variable can be anything. I can just say a, but it doesn't make sense. What it does is it takes each item one time and runs through the loop. So for example, it will look for first time when it runs, it takes apple, and the value of fruit is apple in this case. In the second run, when it runs through it again, it will take banana and assign it to fruit. Third time it runs, it will take cherry and assign it to fruit. What I'm going to do here is I'm going to say print fruit. So this, let's run it, and we have apple, banana, and cherry. That's what is printed out here. I can do loop through a range, which I mentioned earlier. The way to do it is, let me just first write a comment, loop with range, and inside this I'm going to say for I in range of 5. So what this does is it will create an list of 1 to 5 items, and it will assign each item once inside this range from 1 to 5 and print that out. So if I run this here, it will say 0, 1, 2, 3, 4. So what it does is here it creates, let me just add a comment, create a list of 0, 1, 2, or sequence 4. So these are 5 items. So when you say number range of 5, it will create these 5 items and assign it each every time it runs through the loop. So I'm going to say first time it will take 0 and print that 0. I'm going to comment this out so you can see a better output. Also clear this out so you can see it properly. So first it goes through the first item in the range, which is 0. It prints that out. Next 1, 2, 3, and 4. These 5 items are printed one at a time. If I say 10 here, run this again, 0, 1, 2, 3, 4, all the way until 9. The 10 items we can display here. So this can be used for a bunch of different things. So that's for loop for you. I'm going to comment it out. The next loop that we're going to look at is while loop. Now while loop executes as long as the condition is true. So what I mean by that is you write a condition with while. For example, let me show you the syntax. So the syntax for while loop is something like this. While a condition, so this is can be a variable name, which is a boolean, can be a particular, you can equate things and check if this particular condition is true, and if that is true, then this is the code that it will run until this condition keeps on staying true. So if I say if true, this is how you can write an infinite loop. So it will keep on running forever unless you add some break or something inside it, but we'll cover that later. So I'm going to comment this out right now, and let's go ahead and create an example. I'm going to say create a countdown. I want to create a countdown. I'm going to call it countdown from 5. So I am going to create a variable, say count equal to 5, and then I'm going to say while count is greater than 0, I want to print that count. Now what will happen in this case is, if I run this, is count greater than 0? Count value is 5, so it is greater than 0, so it's going to print 5. Again, it will come again and check, oh, count greater than 0? It is 5, nothing has changed this value, so it's going to print 5, 5, 5 and keep on going forever. So that it does a proper countdown, I am going to say, or reduce the count by 1. So what I'm doing here is, I'm using the decrement operator here, where it's same as saying count minus 1. Instead of doing this, there's a shortcut which is a decrement operator. There's also an increment operator or a multiply operator, division. So all those are available, but what I'm going to do here is I will reduce the count by 1 every time this prints out. So 5 reduces the value of count to 4, and this count is greater than 0. Yes, it is. So 4, 3, 2, 1. Then when its assigned value is 0, is count greater than 0? Nope. It will come out and come here where I'm going to say outside while loop. So that's what will happen. So let's go ahead and play with it. Clear this out. Run it. There you go. 5, 4, 3, 2, 1 and outside while loop. So that's how while loop works. So I'm going to clear this out, comment it out. And go back to my slides. So next, we're going to look at using break and continue for control flow. So I've mentioned these before a little bit, but let's go ahead in more detail of what break and continue does. So first, break. Break terminates the loop prematurely when a condition is met. So if a loop is going on and you want to stop because a particular condition is met, you can use break for that. So an example for that can be, let me just create here. Let's create a for loop for I in range of 10. I want to print I. So what this will do right now is, if I run this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because I'm saying range of 10, I want to print I, so it goes through that. But I want to stop it after 5. So I can say if I equal to 5. So I'm adding a conditional statement here saying that if the value of I is 5, just break out of this for loop. I don't want to run this anymore. And I can always put this here outside for loop. Run this. You see 0, 1, 2, 3, 4, because when the value of 5, it will break out from this for loop and come outside and print this. If I similarly, I can say 7, it will print all the way till 6 and then come outside the loop. So that's how you can break a particular loop. Maybe it's for or while, anything, you can break out of the loop by using break. Next, we have continue. Now, continue skips the current iteration and proceeds to the next one. So what it happens is that if you're running a loop, it will skip that particular operation and run to the next one. So for example, in this particular case, same case, I can give you an example. Continue. So what will happen is, in this case, when the value of I is 7, it will skip that print and go back here. So it will say 0, 1, 2, 3, 4, 5, 6, and then skip 7 and go 8, 9, 10. So it continues to the next loop. So if I run this, let's go ahead. So 0, 1, 2, 3, 4, 5, 6. See, 7 is missing, 8 and 9. Similarly, if I want to miss, let's say 5, run it. 0, 1, 2, 3, 4. I can skip something and run, still continue running the loop. So that's what continue is used for. Let's look at one more example here. So what I'm going to do is I'm going to clear it out. I'm going to comment this out. And I'm going to say for I in range of 10. And in here, I am checking if I mod, I'm not sure if you've used the mod operator, but it gives you if it's divisible by 2 or not. If it's divisible by 2, I want to continue, not break, and go to the next one. So this will print only if odd numbers. So if I run this, 1 3 5 7 9. So what's happening is it's going through this if range 0 to 10, but when it checks 0, it will say, oh, 0 divisible by 2 is 0, whereas 1 divided by 2 is 1. So it will print 1. It will not go inside this loop. But for 2 divided by 2 is 0. So it will skip this, and so it will run through 0 to 10, and it will only look for odd numbers because even numbers are divisible by 2 and the value is 0. So it will continue and skip that particular loop. So that's why I see all odd numbers here. So now that we have completed all the different conditional statements and loops, control flow types, so now we can jump into our hands-on exercise. Our first exercise is to check if a number is prime. So here the main objective is to write a Python program to determine if a given number is a prime number. So for this, first you need to know what a prime number is. A prime number is only divisible by 1 and itself. We can use a loop to check divisibility for numbers between 2 and the square root of the given number. That's what we can do, and we can break the loop if a divisor is found in this particular case. So that's how you can get prime numbers. So let's go ahead, and I'm going to leave it as it is, this one. I'm going to create a new file, save it as day 2 exercise 1.py. Now here, first let's get the number equal to int, and instead of me giving a number here or setting a variable with a number, what I'm going to do is I'm going to ask the user who is going to run the command prompt to give me that number. So I can use input, and I can ask the user enter a number. So there you go. And now I'm going to say if number is greater than 1, first of all, inside here I am going to check for I in range of 2 comma integer number raised to 0.5 plus 1 if num mod I equal to 0, then in this case this is not a prime number. So just to go over it again, just to understand better, what I'm doing here in the first line is I'm asking the user to enter a number, and I'm converting that number into an int right over here, and that number I'm saving inside the variable num. Next, I'm checking if the number is greater than 1. This checks if the input number that I've saved here is greater than 1. But why am I doing it? Prime numbers are defined as integers greater than 1 that are divisible only by 1 and themselves. So that's why I am checking if the number is greater than 1. If not, it will skip the program and then proceed to check if it's prime. So if not, then it will skip to the else block at the end, which we'll write in a little while. But right now here, once let's say if the number is say 13, it's going to check here in line number 3 to 7. What it does this is range 2 comma integer num times multiply 5. What it does is it generates numbers starting from 2 up to the square root of num. So this is how you get the square root, rounded up to the nearest integer plus 1. So that's what's happening here. Now why am I doing square root here? If a number is not divisible by any number less than or equal to its square root, it's prime. This optimization reduces the number of checks. So for I in this thing, it iterates through each number I in the generated range to check if number is divisible by I. So that's what it's doing here. So next, in this particular line, if num mod I equal to 0, it checks if the number is divisible by I using the modulus operator. If num mod I equal to 0, it means num is divisible by I, so it's not prime. Next thing is to let the user know that. So I'm going to say print, and since I'm going to add a variable, you start with f, and then here is what you pass the variable inside the curly brackets is not a prime number. So this will show it like that. And I'm going to go and break out of it here. So this will break out of my current loop. Else. Now else is for this particular case, I am going to say, I am going to print f number is a prime number. Now I have one more if, like let's make sure we are all aligned on which if I'm writing that to. And I have one more if on the top. For that I'm going to else print f of number is not a prime number. Oop. Is not a prime number outside. So what's happening here is in the else loops, uh, once I break out of here, if it's not a prime number, that's done. Next, what I'm doing in the following lines is I am printing. So if it's not a prime number and if it doesn't mod this, so I am saying else it's a prime number. That's what I'm saying here. And finally, the last else block is associated with the for loop where, so when does this execute? If the for loop completes without encountering a break, no divisor was found, that's when this will run. So it has to be kind of given right outside for loop. And then the final one, it prints. So what happens in the end is this else block belongs to if number is greater than 1 statement, which means this will execute saying that if the number is not greater than 1. So for example, if it's 0, 1 or negative numbers, this will run from here. So let's go ahead, save this and run this particular code. I'm going to say Python day2 underscore exercise 1.py. So it's asking me first line, enter a number. So let's say I will enter 10, which I know is not a prime number. Say 10 is not a prime number. I am going to go and run it again. And this time I'll give 13, which I know is a prime number. And it says 13 is a prime number. So it goes through the loop, finds out that it is not divisible by any of these numbers. And that's why it's going to go and say it's a prime number here. So that kind of completes our first exercise where we have created the code to find out if a number is prime or not. Our next exercise is to create a menu driven calculator. The objective here is to create a Python program that takes user input to display a menu with simple math operations, where we'll be doing addition, subtraction, multiplication, and division. So the instruction that I would want to give you before we start is we'll have to present a menu with options, just like how we did before. But before we asked user to, in exercise 1, we asked the user to enter a number. But here we'll give them a menu of addition, subtraction, multiplication, and division. Then we'll allow the user to select an option and input numbers. Then perform the selected operation that user wants and display the result. We'll use a loop to repeat the menu until the user exits. So first, let's go ahead and create a new file. I'm going to save this and I'm going to say day2 exercise2.py. Here, let's start with the functions. We have not yet covered functions, but it's better we go through it as and when we learn it. So what I'm going to do is I'm going to create a function called add, which adds two numbers. I'm going to give two parameters a and b. Now, if you don't understand what I'm doing here, just follow along, and in the next section we'll learn more on these. And here I'm going to say return a plus b, because that's how you add two numbers. Next, I am going to say subtract, and that again takes two numbers a comma b, and this one returns, so this function will return a minus b. Next, I want to do a multiplication. I'll say multiply, and I'll take two numbers a comma b, and I will return a times b. Next, I am going to do divide, and this again will take two parameters, and this will first in division, sometimes you check if it's not equal to 0. So I'm going to say not divisible by 0. So b is not equal to 0. So I'll have to make sure that division by 0 is not allowed here. So I am going to check if b is not equal to 0, because a divided by b, and in this case the second argument, if it's 0 or not 0, I will say return a divided by b. If the user gives me a 0, I am going to print out saying, or return back saying, division by 0 is not allowed. Just an extra precaution here. So these are my four functions to add, subtract, multiply, and divide. Now I'm going to write a loop here. I'm going to say while true. Again, as I mentioned, when you say while true, it will run on a constant loop. Now to break out of it, you can just say break. But where should I say it break? So first, as I mentioned, we need to give a user a menu option. So I'm going to say print, and in here, next line /n adds the next line in the terminal or a command prompt. I'm going to say menu. Now the menu, I will give user options where, so this one is for addition, subtraction, multiplication, division, and exit. So I think I have all of them. Number one, so if user says number one, with an addition. If the user presses number 2, I will say subtraction. If the user presses number 3, I'll say multiplication. If the user presses number 4, it's division. Number 5 is to exit. So which means if the user presses 5, I will just exit out of the loop. So if you want to see how that is done, I can just say if let's get the choice first from user. So I'm going to say choice equal to input. I'm going to ask user, enter your choice based on the above menu. So based on the above menu, I'm going to ask the user to enter something, and if the user picks, let's say 5, what I'm going to do is I'm going to say print exiting program, and I will break out of this code. Break out of while loop, which is end of this function. There's nothing else outside it. Or else I'll ask the user to enter the two numbers. I'm going to say number 1, I'll take it as float because user might enter decimal point values, and I'll ask the user to input something. I'll say enter the first number, and I let user enter his first number, his or her first number. Number 2, float, enter second number. This is where the user will enter the second number. Now I have both the numbers. What I'm going to do is I'm going to check if choice equal to 1. If the user selected 1 as his choice, which is addition, so what I'm going to do is print result is add. I'm going to call the function add, which is right here, and it needs two parameters, which are my number 1 and number 2. So I'll pass that. So what it does is, if the user picked 1 here and then entered 2 and then enter the second number as 4, I'm going to pass this 2 and 4 to this add, which is 6, and it will show me print the result equal to 6 in this particular case. So that's the first one. So I'm going to copy this few times. Now I can't do if because what it will do is it will go through each and every one 4 times. 1, 2, 3, 4. So this is 2, 3, 4. If I leave it like this and add the functions, subtract, third one was multiplication, and the last one was subtract. So these are the different options. Now if I run it through here, it will check each and every time, but I want to see, like, if I'll check 1, if it's not 1, then I want to check the second one. Or else what it will happen is, even if the choice is 1, it will go through each and every statement. Else this one. Now what if user types anything other than 1, 2, 3, 4, 5? So for that I will say else print invalid choice, please try again. So for example, if the user presses 9, we don't have the anything to do with 9. So I'll say invalid choice and I'll ask the user to try again. So go ahead and run this. Let me clear this out. This is called day 2 exercise 2. So here is my menu. Addition. So this printed out addition, subtraction, multiplication, division, exit. So I am going to say 1. Now it says enter your first number. I say 3. Enter second number 5. Now 5 plus 3, and as you saw that I took the input as float, so it will take it as 3.0 and 5.0 and print out 8.0 for me. Similarly, if then again it will run through the while loop again. Since I've not exited the loop, 2, let's say 5 and 1, let's say 4.2 is the result. Similarly, if I pick 3, let's say 4 times 5 should be 20. Now 4, I want to divide 4 by 0. So looks like here in the code, instead of calling the divide, I was calling the subtract. So I'm going to fix that and go ahead and run my code again. Give the option 4 and say 4, second number 0, and it's a division by 0 is not allowed. Let's go ahead and pick 5, exiting the program. So that's our exercise number 2. I hope you were able to get through it. If you have any questions or any problems, let me know. And for the next things, what you can do is, for additional practice, I have a couple of more programs for you. What you can do is you can write a program to calculate the factorial of a number using a while loop. Now, if you don't know what a factorial is, go ahead, look it up, and then write this to create to calculate the factorial of a number using a while loop. Next, you can try to create a program to find the largest number in a list using a for loop. So you can try that out. So if you have a list of items, so create a list of items and add some numbers inside there and use a for loop to go through each and every item in that particular list and find the largest number in the list. So that's it for day 2. Welcome to day 3, where we will be covering functions and modules in Python. We'll start with defining functions with DEF. Now, we've already done this in the previous day or yesterday, but we're going to go in more details about what are functions. Now, function is a reusable block of code that performs a specific task. Functions improve modularity and code reusability. It helps you, like, for example, if you see somewhere that you're repeating the same code over and over again, just create a function out of it and call that function from one single place. So in future, if you have to change something, you change only at one place and don't have to change every single place where you have the same functionality. Now, defining a function. To define a function, you use the def keyword, as we saw in our calculator example in yesterday's video. So you use the def keyword to define a particular function. Now, the syntax for that might look like, I'm going to create a file, save it inside our day 3, call it day 3 samples.py, and here if I want to create a function, you say start by saying def, then comes the function name. So here is the function name, whatever name you want, you feel like you give here, and then the parameter. So whoever is calling this particular function needs to send parameters. It can be empty too. If you don't want to send anything, it's just like say print hello, for example. You don't need to add any parameters in here. But if you want to add two numbers, then you add two different parameters here that are passed. And below it, so next line, it goes where code block goes. Now a function can return or not return something. If you want to return something back to whoever called it, like how we did in our calculator example, you can use the return keyword and pass a result back to the calling variable. So again, as I mentioned, parameters are values passed to the function for processing. The return values are values returned by the function after the processing. Let's look at some examples in this case. So we already created that file. I am going to comment this out and here create a function with parameters and return value. So I'm going to create a function. To create a function, as I mentioned, you use def, and then I'll say this is for my addition. I'm going to say add numbers. That's what I want to call this function. You can call it anything you want: add, addition, add numbers. And I need to send two parameters because I want to add two numbers. You can also add three numbers if you want and add a third parameter over there, but I want to make it simple where it adds two numbers a and b and returns it back. Now I can return it directly like this. You can also do is inside here I can create a variable c and say a plus b and return C. So that is also possible, but less lines is always better. So I always like to say A plus B instead of doing this. I'm going to comment this out. And now to call it, let's say a variable result wants to add two numbers. It can say add numbers and pass two numbers, for example, 5 and 3 in this case. And I want to print that summation of addition of those two numbers. I can just print that result variable out here. If I go to my prompt, you can say cd day 3, and here I have day 3 samples. So I'm going to say python day 3 samples.py and sum is 8. So similarly, I can change here 45, let's say that says 48, which is 45 plus 3. Clear it out. So that this is how you can create a function. Again, the function is created by the keyword def, where you're defining a function, then the function name, whatever name you want to give, the parameters that it has, or if you don't want to pass any parameters, you can just skip it. For example, in this particular case, I can just say add two numbers and I can just return two numbers like this, run it, and it will add two numbers and return it back. But you have to change the variables here, which doesn't make any sense, but this is how you can call a function with no parameters in there. So now next, now that you know functions, let's look at scope and lifetime of variables. Now scope has two different types of scope. One is called as a local scope, where the variables defined in the function are only accessible within that function. Which means, for example, if I create a variable c here, the scope of this variable c is only for this particular function. If I use c here, it will not know what c is, and it will probably say, oh, nothing, I don't know what c is. So that is called as a local scope within a particular function. We also have something called as a global scope, where variables defined outside functions are accessible throughout the program. So that's the global scope. We also have something called as lifetime, where local variables exist only as long as the function executes. So what it means is the local variable that I created, for example, the C that I've created here, only exists as long as the function executes. As soon as the function is done executing, those variables do not exist. Global variables persist throughout the program unless it's modified within a function using the global keyword. I can show you some examples. For it to run into examples, let's first go ahead and comment it out. Let's start with the local scope. So for local scope, I am going to create a function called as greet, and inside here I am going to say message equal to hello world. Now this is a local variable inside this greet function, which means if I try to use that outside, it will not know what is the value of this variable. Now if I call the greet function here, this should call this this will call this function and print the message. But if I try to print something like message here, it will not know, because this function, this message variable, is local scoped only to this function. It's not available outside. That's why we indented, just so that we better understand this. I can go back here, clear it out, and run that, and you see it gives me an error. It says name message is not defined. It doesn't know where it's defined. What are you trying to do here? So this gives you an error. If I remove it, it will just work as same as before, but doesn't try to run this, and it will not give you a message. So if you want to use this outside, one thing that you can do is you can use global scope. So let's comment these out. And let's look at global scope. Now, in case of global scope, I'm creating a variable called as greeting equal to, let's call it hi, and I'm creating a function called as say hello, and inside here I am going to say print greeting. So what's happening is the message that I've created here, I have created that variable outside, which means it's available here inside the function, as well as I can just say print greeting outside the function too, and it will not give me an error, because if you see where the variable is defined is outside the function and is also accessible to this print statement right here. Now if I run this here, I will not have any error. It will say hi from here and then hi from here. This I can just concatenate it from inside the function, and this one I can say from outside the function. Run it. Hi from inside the function, because it calls this, it will print it, and then it will print this same hi message from both inside and outside the function. So that's how you can create a global scope for this. Next, let's look at importing and using modules. Now, what are modules? Modules are Python files containing a collection of functions and variables that can be reused. So instead of creating functions, if there are a lot of things that you are doing and want to reuse among different teams, you create modules. So modules again are Python files containing a collection of functions and variables that can be reused. Built-in modules can include something like Python has already given you some modules like math module, OS module, and random module. So first, let's look at importing modules. So there are different ways you can import modules. You can import an entire module, where I can give you an example here. Just comment this out. So if you want to import an entire module, you do, for example, I want to import the math module. So I'm going to say import math. And in here, now I can use that module by saying math dot, there is a function called a square root in there. Let's call that square root of 16. If I run this, so I don't have to write the code to actually uh, get a square root of a particular number. I can just say math dot square root, and if I run this, it will say 4 is the square root of 16. Next is importing specific functions. Now math has a lot of different functions. What if you want to only import a particular functions? In this case, I want to from math, I want to import square root. So that way I don't have to write this. I can just say square root of 16 and it will know what I want to do. So go ahead, run it, and it gives me the same result, because of course instead of importing an entire module, I'm just importing a particular function from that module. Another thing that you want to know about importing modules is using aliases. So here, instead of calling it math, I can call it, sometimes the module names are really big, so I can just say math as m. So I can use an alias here, and then I can say m dot square root. Sometimes, let's say I create a module called as Vivian is dancing on the mountain top. So I can just say import Vivian is dancing on a mountain uh, top as viv, something like that. So there are some functions that there'll be some modules that you'll see which have really long names, and if you want to use a shorter version of it, this is how you can use aliases to create this. Now, another option is creating your own custom modules. Now, sometimes what will happen is you'll have a lot of functionality that is available in your code, and you have multiple files, and you want to reuse these modules in different files. So what you can do is you can create a .py file with custom functions and variables inside that particular Python file, and you can import that into another script using import and the name of the module directly. We'll see those in future, but that's how you can create your own custom modules, where you have a lot of code which might be needed in different places. Then you can use that. One example I can give you is, for example, let's say you have a organization which has 5 different departments, and they have the same login because the organization has the same login behind it. So instead of creating the login functionality every single time for 5 different departments, you just create that component or a module one time, and then let all these departments import that module into their code, where every time a user comes in, they can log in. So that can be a good use case of creating custom modules. Now, let's jump into hands-on exercises. Our first exercise today is creating a function to calculate factorials. Now, I've given you something similar as an exercise in the yesterday's video, but here our objective is to write a function to calculate the factorial of a number and call it within another function. So first we will define a function called as factorial n that calculates the factorial of the number n. Then we'll create another function called as print factorial n as a parameter that calls the factorial function and prints the result. Let's go ahead and write the code for it. So I'm going to save this and close it, create a new file, Python file, save it inside my day 3 as exercise 1. And here, first, let's create a function called as factorial of n. Now here, I'm going to say if n equal to 0 or n equal to 1, what happens to factorials? If n equal to 0 or n equal to 1, that means I just return 1 in this particular case. Else, I will call the same function. So I'm going to say return n times factorial n minus 1. So what I'm doing is I am reducing that number by 1 and multiplying whatever the result is from this particular, keep on multiplying. So that's what factorial is. If you don't know what factorial is, for example, if I say what is factorial of, let's give an example of 5. 5 factorial is 5 times, reduce that, sorry, do something like that. 5, the first number, n times, reduce that number by 1, 4, run it here. So which means 4 times, it will call it 3 times. Now the number will be 2. Again, it will call this times. Now it will be 1. In that case, it will return back 1 here. So this will give me 5 times 4 times 3 times 2 equal to 120. You can do the math and check it out, but that's what factorial of 5 is, or we can run the function and check it out in a little while. So what I can do here is I'm going to say create another one function, and this one is to print a factorial, print underscore factorial n, and here I will say result equal to factorial of n, and this is used to print the factorial of n is result. So that looks good. And now let's test this function. I can call it, I could say print underscore factorial and pass a number. 5 is what we wanted to test. So this will call this function and it will get the result from this particular function, which is just only doing, what I'm doing is I'm kind of separating these two here. The reason is so I can kind of separate the functionality of finding a factorial and printing a factorial separately in 2 different functions. I will save it, go here, clear this out, Python exercise 1.py, and it says factorial of 5 is 120. I can change the number 10. Factorial of 10 is 362. Give something simple. Let's say 2 times 1 is 2. So 2 times 1 is 2. So that's why factorial of 2 is 2 in this particular case. So this is successfully completing our exercise where we are printing a factorial of a given number. Our second exercise is to build a custom Python module. Now, objective here is to create a module with basic math operations and use it in a main script. So let's create a Python file called as math operations with functions for addition, subtraction, multiplication, and division, something that we've done in a previous day. And we'll import and use this module in another script. So we'll create two different files. So first, for this, let's go ahead here. I am going to call it, since it's a module, I am going to call it math underscore operations dot py and save it inside day 3. Now here I'm going to create a bunch of functions. Let me do that. A comma b, the addition will return back a plus b. Next is subtract a comma b, and this will return a minus b. Next one is to multiply a comma b, and then here I can say return a times b. Next is divide a comma b. Here again I will check if b is not equal to 0, then I will say return a divided by b, else I will say return division by 0 is not allowed. So I have 4 different functions here inside my mat.operation where it does addition, subtraction, multiplication, and division. Now I will create a main script, or create another script. I'm going to call it exercise2.py, and inside here I am going to import that math underscore operations as mo. So I'm going to use the alias that we did. Next, I'm going to say number 1 equal to 10, and I'm going to say number 2 equal to 5, and then I'll say print addition is mo dot add is a function that we have there, and I'm going to pass number 1 comma number 2. So my 2 numbers. Let's see if it works just for addition, so we can do more after that. Clear this out. Let's say Python exercise2.py, and it says addition is 15. So what it did was, since it's in the same file, it picked up a same folder, it picked up this file and imported as mo, and then when I added these numbers, it called this function to add and then ran it here. So similarly, now I can add the other 4, which is subtraction, multiplication, and division. And here I'm going to say divide, multiply, subtract, and add. So now if I run this, say 10 plus 5, 15. 10 minus 5, 5. 10 times 5, 50. 10 divided by 5, 2.0. And there you go. We have our function here, or we have our main code here, main exercise2.py, where we are printing out all the different functions from our module that we created, which was called math operations here, which has all the functions in there. Now I can use the same thing in this exercise 2. I can call it in exercise 1. I can create another file and have them import this particular module and use it over there. So I hope you were able to follow along. If not, let me know if you had any problems. But next, for additional practice, I would say that you can try to create a function to check if a number is even or odd and call it within another function. And then try to create a module for string operations, including functions to reverse a string, count the vowels in there, and check for palindromes. Now import it into a script and test the functions. So you create a module and then import it in another script and test if it works for you. So today in day three, you had some hands-on experience in defining functions, understanding variable scopes, and working with modules. By practicing with built-in and custom modules, you developed reusable modular code, a critical skill in AI and software development. So this will be very much helpful in our future videos. So I hope you followed this along nicely, and if you had any problems or questions, let me know and I'll get back to you. Day 4, data structures. Here we are going to cover lists, tuples, dictionaries, and sets. Now we probably have used some of them before, but let's go deep dive into each one of them. Let's start with lists. So what are lists? Lists are ordered, mutable collections that can hold a variety of data types. When I say mutable, that means they can be changed and appended, deleted, edited, all those things. When it's just immutable, that means once you create them, it stays as they are. So lists are again ordered, mutable collections that can hold a variety of data types. Now let's see how do you create a list. So I'm going to start with an empty project, create a new file, Python file, save it inside our AI Bootcamp week 1, create a new folder for our day 4, and here I'm going to say day 4 data structures .py. Now here, now to create a list, let's say I want to create a list of numbers. So I'm going to say numbers equal to, create these numbers 1, 2, 3, and 4. So this is a list of 4 numbers 1, 2, 3, and 4. I can create a list of fruits where I can say, so again, square brackets, I can say apple, banana, and cherry. So this is my list of fruits, which are list of strings inside here. This was list of integers. This is list of strings. I can have a mixed list too, which has combination of both or more. So 1 is a number. I can have apple, and I can also have boolean in here. The third element is true or maybe false. So that's how you can create a mixed list. Now next I want to talk about accessing these elements. Now you can access these elements by index. So what I mean by that is, so for example, if I want to print numbers and I want to print this is the 0th element, first and second element, and this is the third element. So the index is 0, 1, 2, 3. Again, for this is 0, 1, and 2. 0, 1, and 2. So if I want to access the third number, which is 3, 0, 1, and 2, so that's the index, and that's what I'll pass here. Similarly, if I want to access the first fruit, I'm going to say fruits of 0. If I want to access inside this mixed, I want to access the second element, which is apple, I'm going to say 0 and 1. So this is first element, 0, 1 index. I save it. I can run it here. You can say ls cd day 4, and I'm going to say python day 4 data structures. And if you see, this is 2, which is this one, apple, and the apple again. So I can change this to 0, 1, and 2, which is cherry. So index 2 can print it out, 3, cherry, and apple. Perfect. So that's how you can access this element, by accessing through their index. That's what it's called. We also have something called as negative indexing. What happens here is, so for example, if I say that fruits of -1, so what will happen is this is the index 0, 1, and 2. Now if you go in the opposite direction from here, 0, -1 will be the last item here, -2, -3. So if I say fruits of -1, it should give me cherry. So if I go here and print it, it will give me cherry, because index of -1 is, this is 0, so the last one is -1. So that's how you can use negative indexing. We also can, next we're going to talk about modifying these lists. There's 2 different ways you can modify a list, where you can add items and you can remove items. Now if I want to add items, For example, in my fruits, I want to add more items. I can just say here, let me comment these print statements out, and I can say fruits dot append. So that's the keyword append, adds to the end of a particular array. So in this particular list, I have apple, banana, and orange. I want to append another one. I can say orange. Another way of appending or adding items is I can say fruits dot insert. In this case, I want to insert at a particular index, let's say index 1. I want to insert grape. So this inserts at index 1. So this is index 0. So this is index 1 right now. So this will insert grape in between apple and banana. So if I print fruits right now, the entire array will look something like this. Apple, then grape was inserted, and banana and cherry are there. And since I appended orange, orange showed up at the end. If I don't do this here, run it again, I have apple, banana, cherry, and orange. If I don't do this, I have apple, grape inserted at 1, and then banana and cherry move one index to the right, and that's why we have 0, 1, 2, 3, where grape is inserted at index number 1. Now if I want to remove something in here, so I'm going to keep all of them, clear this out. Now if I want to remove something, what I can do is I can say fruits dot remove, and I can specify what I want to remove. So for example, if I want to remove banana, so I can just say remove banana. So if I do that, run it, it will say apple, grape. Okay, I didn't print it again. Let's go ahead and print this after the removal of how it looks like. So before and after. So before I have apple, grape, banana, cherry, and orange, but after I removed it, it removed banana from here and moved everything one index to the left. So cherry came here, orange came here. So index is 0, 1, 2, 3. You can also delete by saying delete fruits at index, let's say 0. You can print it out just to show you how this works. Go here. So if you see apple, grape, banana, cherry, orange, then I removed banana, so it became apple, grape, cherry, and orange. Then I said delete fruit at index 0, so it removed apple and moved everything one index to the left. That's why we have grape, cherry, and orange here. Another option is if you want to remove something from the top, you can say fruits dot pop. What this does is it removes the last element. So if I go ahead and print it now, let's clear this out. And now you have, if you see that we did this apple, grape, banana, cherry, orange. We removed banana, so we had apple, grape, cherry, and orange. Then we removed the first item, which is apple. So we got grape, cherry, and orange. Now when I said pop, it popped the last item, which is orange. If I call it one more time, it will remove even the cherry. So it pops two of the items. One is orange and one is cherry. It will pop items from the last elements, from the last indexes. Next, let's look at slicing lists. Now, slicing is kind of getting elements from a particular place. So, for example, I just want to get grape and cherry from this particular fruit. How do I do that? So, I am going to first remove my delete statements from here. Still display this. So, I have apple, grape, banana, cherry, and orange. Now, I want to get, let's call it sliced fruits, and here I am going to say I want fruits from index 1 to 3. Let's print this, print sliced fruits. So this is how you can slice a particular list of items where it takes, like what is printing is 1 to 3. So 0, 1, so this is the first one, 2, banana, and it doesn't take cherry because I said 1 but before 3. That's what it means. If I say 1 before 4, it will display grape, banana, and cherry. I can just say 2 to 4. So depending on which items you want, so 0, 1, 2, 2, and before 4, so that is banana and cherry. So you can kind of slice a particular list into a smaller list and use that for some other operation you want. You can probably think of thousands of different operations that you can do with this right now, but that's how you kind of slice a particular uh, list of items by giving this index colon index syntax. Next, now that we have completed list, let's look at tuples. Now, tuples are similar to list, but what exactly are tuples? Tuples are ordered, immutable collection of items. Unlike list, which were ordered mutable collection, tuples are immutable, which means you can't change them. Now, let's look at how to create tuples. So, I'm going to go back here again. Go ahead and comment everything. Go all the way to the top here. And first, let's create a tuple of colors. I'm going to create a tuple by giving the rounded brackets. And here, first is red. My favorite three colors, red, green, and I guess you guessed it, blue. So these are three colors. Now in here, I want to create a single item tuple where what you have to do is, let's say I would say glass. And if you want to create a single item tuple, you need to put a comma at the end of it, or else it will not take it as a tuple. So for tuples, you make sure that if it's only single item, you have to give the name of the first element, or the first element that is either a string or maybe a number or whatever it is, and then give a comma next to it specifying that this is a single item tuple and this is a three item tuple. Now, next thing that we'll look at, how to access elements in a tuple. It's very similar to list, since it's ordered list. It's an ordered item, ordered data structure. So you can just say print colors and you can just say 0 and get the first color. You can also use the negative indexing as I mentioned, and it will give me blue, the last element over there. Can clear it here, run this, and you'll see red for index at 0 and -1, which goes the other way around, and that's why we get blue here. Now again, something that we want to remember is immutability. Tuples cannot be modified after you create them. However, they can contain mutable items like list inside them. So we have strings here in this particular case, but you can have list inside there, which and list can be mutable. So that's how you can create a mutable list of tuples. Next, let's look at dictionaries. So first, what are dictionaries? Dictionaries store key value pairs for fast lookups. Now in case of list, it was ordered. In case of tuples, they were also ordered. So you can access them using 0, 1, 2, 3. But in dictionaries, you access items using the key value pair. So you can access a value using the key item. So let's see how we create dictionaries. So I'm going to create a dictionary here. Again, comment it out and move it down. For dictionaries, I am going to let's create a student dictionary. And to this student, I'll give a name, and name I'll give Alice. Age, I'll give, let's say 25, and grade I will give as, let's say, A grade for Alice. So this is how you can create a key value pair where the key is, in this particular case, name, age, and grade. These are different keys, and values are Alice, 25, and A. So unlike list where you have like in ordered 0, 1, and 2, here you don't have an order, but you have key value pair. If I print this student, go back here and print it, you see name Alice, age, and grade. You'll probably see the way it is specified here. It's not an ordered item, so it might be saved in any order. The way it's accessed is through the key value here. Now let's talk about that accessing and modifying data. Now to access, first you'll probably can access this the values inside here from the key. So I can say what is the name of this student, and when I print that, it says Alice. So that's how you access. So you can say age here and you can get age, or you can say grade and access the grade of this particular student. The next thing that we want to talk about is adding and updating. So what if I want to add something to this particular uh, to particular group. So I can just say, let's move it here, print the entire student. And then to the student, I want to add a stub subject. I can say student inside square brackets. I know square brackets are used for list, but when you are assigning a key and a value, you can do it using this. I can say subject that I want to add to the student is math. So this creates a key value pair. If I print this out, probably say name, age, grade, and subject all displayed here. Clear it out. And again, now if I want to update something, you can again do it similarly. You can say that I want to update the age from 26 to 32. Now if I print it out, you'll see name is Alice, age has got updated to 32, grade is A, and subject is math. So this is how you add and update items inside a particular dictionary. Next, let's look at how do you remove items. Again, something similar to list, you can just say use del student and a particular item you want to delete. For example, I want to delete the grade. That's how you can remove it. Also, let's print it out first. And then you can also use the pop. I can say student dot pop, but in this case you can't give empty. You'll have to specify what you want to pop. So I'll say subject is what I want to pop. Take this, print it out. Let's display it. So first one, this is the original one, and then I said delete the grade, and if you see grade is missing here. Then I said pop subject, and if you see it popped subject out of this particular dictionary, and now I only have name and age here. Next thing that we want to talk about is iteration. Now, how do you iterate through a particular dictionary? The way to do it is, because for lists and sets is easy because they are indexed, but if I want to iterate over a particular dictionary, the way to do it is for key and value in student dot items. So what it does is it puts everything inside student with the calling this function student dot items, puts them in a list. This is what this function does, items. And now you can access each key and its value from the student dot items function. So I can just say print here key and value. So this will show me what will I get when I do this. So see, name is Alice, age is 25, grade is A. So it created a list of key value pairs from a dictionary, and then I can iterate over them one at a time and display those values. Next, let's look at sets. Now, what are sets? Sets are unordered collections of unique items. So the one thing that you have to remember in sets is you can't have repetitive items. Like for example, if you have a number, a set of numbers 1, 2, 3, 4, that's fine. But what if you have 1, 1, 2, 2, 3, 3, 4, 4? Then it will kind of drop those duplicates and it will give you a set of 1, 2, 3, 4. So a set or sets are unordered collection of unique items. So how do you create sets? To create sets, just first make sure that this is commented and go down here, create numbers equal to again angular brackets 1, 2, 3, and 4. So it's not key value pairs because inside angular brackets key value pairs are dictionaries, but if you use angular brackets with items inside here, that's an unordered collection of unique items which are sets. You can also create an empty set. For example, I create just a variable name called an empty set, and to create an empty set you can just say set empty. That's how you can create an empty set. Now, how do you add and remove elements from a set? I think that's the next topic, adding and removing elements. To do that, first I can just say inside numbers, I want to add 5. So let's print numbers here first. And after adding, let's print again. Let's run it. We clear it out first, run it. It says 1, 2, 3, 4, and if you see 1, 2, 3, 4, 5, so I've added one more item. What if I want to add, what if I try to add 4? It will say 1, 2, 3, 4, and the output is again 1, 2, 3, 4. Why? Because 4 already exists, so you can't add duplicates. You can add some other numbers, but no duplicates. As long as there's no duplicates, it all works fine. Now, what if I want to remove something? So I can just use something similar and say remove, and I want to remove, let's say 2, and let's run it. So I have 1 2 3 4 8, and if you see here 1 3 4 8, so 2 got removed when I call the remove function on a particular set. Next thing that I want to talk about is set operations. Now you probably have learned about this before, but set has three different operations. First is union, which is union of two different sets. When you try to, so for example, I have this, or let's create a new one. I'll remove this. Set 1 equal to, I have 1 comma 2 comma 3, and I have set 2 which has 3 comma 4 comma 5. Now if you see in this particular case, if I try to union or put both the sets together, set 1, and union is done using the pipe symbol, so I'm saying set 1 pipe set 2. In this case, let's look at the output. First I'll clear it out and then run it again. 1 2 3 4 5. What happened when I unioned them? It took both of them, put them together, but since there is 3 that is duplicate, it used 3 only once. 1 2 3 4 5. That's what union is. Next that we want to talk about is intersection, which is intersection between two different sets. So in that particular case, you can use the and sign, something like this. Now the intersection between these two sets is 1 2 doesn't exist, but 3 exists in both of them. So 3 is the intersection point. So if I run it, I get only a set with value 3. So that's intersection. Next, we talk about difference. Difference is from first set, what is the difference as compared to the second one? That is done by using the minus symbol. Now, look at the first set and the second set. The second set will only check the difference for what is there, not there in set 2. So that is 1 and 2. So this will give me difference of set 1 and set 2, which is 1 and 2. So if I run this, there you go, I have an output which is 1 2. So that's the difference between set 1 and set 2. So we created union using the pipe, we created the intersection using and we created difference using minus. So that those are basic set operations that we have available. I'm going to comment this out, save it, close it, because next we're going to jump into our hands-on exercise. Our exercise 1 is to manipulate data in a dictionary. The objective here is practice adding, removing, and modifying key value pairs in a dictionary. So first, what we'll do is we'll create a dictionary to store information about a person. We'll perform different operations like adding a new key value pair for the person's address. Then we'll modify the age key to update their age, and we'll remove the grade key if it exists. So let's go ahead, create a new file, call it a Python file, save it inside day 4, call it exercise 1. And here, first I'm going to create that person key value pair. Name is Alice. Next, I'm going to say the age of this person is 25. Next, I want to give a grade, and the grade is A grade. So this is my person. Now the first thing that I want to do is add new key value pair. So as I mentioned, first thing that I want to do is add an address. So I'll say person address equal to 123 Main Street. So that's the address for Alice. Next, I want to update her age. So I'm going to say update age. So I am going to say person age from 25. I'm going to change her age to 32. Next, if there's any grade, I want to remove those grades from the user. So I am going to check if grade is a different way of doing it in person. So it's checking if the key exists with grade. What do I want to do? I want to delete person grade. So next, I am going to say, so once I'm done with deleting this, let's print this person out. So that kind of completes our entire exercise where we have created a dictionary with three keys with their values, and we added a new key value pair address to this person. We updated the age of Alice to 32 from 25, and then we saw if this grade that is existing, we removed it from there. We can print this here first to check, and then after our operations, let's check it again. So let's go ahead, clear this out, and say python exercise1.py, and there you go. Before, we have name Alice, age 25, grade A. Then we added address 123 Main Street, so it's there. We updated the age from 25 to 32, so that's there. And then we removed grade if it exists, so we removed that grade here. So that's our grade exercise 1. If you had any issues or problems, let me know and I'll get back to you. And let's get to exercise 2, which is word frequency counter. The objective here is to write a program that takes a sentence and returns a dictionary with the frequency count of each word. So what we'll do is we'll take a user input for a sentence here, then we'll split the sentence into words, and then we'll count the occurrence of each word and store the counts in a dictionary. So let's go ahead and you can follow along. If you had any problems, let me know in between, but I'm going to start with exercise 2.py, and here first let's take an sentence as input from our user. I'm going to say enter a sentence to the user, let them enter, give us the input. Then I want to, let's write this down, split the sentence into words. Now that can be done by creating an first a parameter, a variable words, which is a list. Now to this list, I'm going to call the split function. So what this does is split function. It will take a particular sentence and split it and put it inside this words list. So that's what it will do. Next, let's initialize a dictionary. Initialize a empty dictionary. To do that, I am going to say word underscore count equal to empty dictionary. Next, now I want to count the word frequency. So to do that, I am going to say for word in our words list. So I'm going to go through each and every word, and I'm going to say word equal to word dot lower, because the user might have entered the same word. For example, I can say uh, AI in capital or AI in small a couple of times, and then it would take them as two different words. So I'm converting to lowercase for case insensitivity here. Next, I'm going to check if word in word underscore count. So I'm checking if this word has been counted before. If it has been counted before, I am going to say word underscore count for that particular word. I want to increment the number to 1. Else, I'm going to say word underscore count for this new word that we came across. I am going to say equal to 1. And that's it. So let's go ahead and print our word count at the end of it. So there you go. So we have our code ready here. Let's run it and play with it. So I am going to clear this out. Python exercise 2.py, enter a sentence. So I'm going to say the AI engineer is the future. So it says the comes twice because one with capitalized, one without capitalized. AI once, engineer once, is once, and future once. Let's give a bigger one. So I said the AI engineer is the engineer of the future who would work on different AI projects and build amazing tools. Okay, there's some typos, but that's fine. So the is three times, AI is twice, engineer is twice. As you can see from here, it picked those things and then gave me a word count array here, a word count dictionary, which is what we wanted to do. So now we have our word frequency counter built here. I hope you were able to follow along. If you had any issues or problems, let me know and I'll get back to you. Next, for some additional practice, I recommend you can write a program to reverse a list of and remove duplicates using a set. Then another thing that you can do is create a program that stores student grades in a dictionary and calculates the average grade. Try it out and let me know if you can get that working. Now, to summarize, on day 4, we did some hands on experience working with Python built in data structures, understanding their properties, and performing operations on them. The hands on exercises ensured practical application, building a strong foundation for handling and organizing data effectively in our AI projects. So let me know if you had any problems or issues, and I'll get back to you. Day 5, working with strings. First, we are going to cover string manipulation today. We are going to look at first thing, which is concatenation. Concatenation is process of combining multiple strings using the plus operator or the join method. We have used the plus operator a couple of times earlier, but let's go ahead and look at how it looks like. So I'm going to create a new Python file. I'm going to save this inside my week 1 day 5 and call it day 5 underscore strings. Now here I can create a string first, which is, let's call it hello, and then I'm going to create another variable string which is world. Now if I want to concatenate these two together, I can say result equal to first plus, I want to space between them, so I'm going to say space, empty space, and second. Now this, when I print it out, I will see hello space world. Now to run it, I'm going to clear this out, cd dot dot slash day 5, and I have my day 5 strings here. I'm going to say Python day 5 strings. I think I spelled Python wrong. Go again, and it says hello world, which is output of this. So this is how you can combine multiple strings using the plus operator in this particular case. Next, we're going to look at slicing. Now, slicing is the process of extracting parts of a string using indices. Now, we have done this with lists earlier, but let's look at how we can do this using, so I'm going to just comment this out, and how we can do it for strings. I'm going to create a text variable and call it Python programming. Now, I want to just print Python in this case. So I can say from text, I want to see from index 0 up till 6. So 0, 1, 2, 3, 4, 5. I don't want a sixth one. So that's why I said 0 to 6, not the sixth one. You can also have specify that you want to see programming by saying dash minus 11 colon to the end of the space. So what it does is, in this particular case, is going to go until the 11th my negative and then print the rest of the characters. So let's go ahead and run this. I'm going to clear this out, and you'll see for this one it was Python, and for this 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. So this is minus 11 index and until the end of it. So that's why it's giving me programming. So next, let's look at formatting. You can use the f strings or format for dynamic string creation. We already used the f string a bunch of times, which is, let's go ahead, and what I'm going to do is I'm going to create a string called as name as Alice and age equal to 25. Now I can use the f string, which is the format string f, and I can say my name is, inside this specify name, so the curly brackets are used for variables, and I am age, years old. So this is a sentence that I create. Now if I run it, I get my name is Alice and I am 25 years old. So this is very important or very key formatting technique that we use while working with strings. So make sure that you get used to this, and we'll be using quite a lot as and when we progress through our bootcamp. Next, let's look at common string methods. We have split, which splits a string into a list based on a delimiter. So you can specify, like if you don't specify anything, it will use default delimiter is space. But if you specify a particular delimiter like pipe or comma for CSV files, you can use those and split a particular string and put it inside a list of items. We also have join, which joins elements of a list into a single string. And we have replace, which replaces a substring with another one. And another one that we want to look at is strip. This removes white spaces or specified characters from the beginning and end of a string. So let's go ahead and play with these one time. So I'm going to go ahead and delete everything. And first, let's start with split, which is split something like this. Now if I have a sentence, so for example, sentence equal to Python is fun. Now I want to split these based on the spaces that it has. You can say sentence dot split, and as I mentioned, default is space. So when I print the words here, clear it out, it's a Python is fun. So it created a list with each one of them based on the space here. Now if I had a comma here, I can specify that comma is my delimiter. So give me the same thing, Python is fun, and uses that as a delimiter. Next that I want to show is join. So that is join. This is the function which joins elements of a list into a single string. So to do that, for example, now whatever words I have here, which is Python is fun, let's move it back to the original one so it looks simplistic. So I have this words here. Now if I want to join it into a sentence, I'm going to say sentence or say new sentence equal to, say space, and I'm going to say join words, and let's print it out. So I'm going to say print new sentence. Let's go ahead, run it. So Python is fun. It took that entire thing and joined the words together using space, because that's what I've created here, and it created this. If I give pipe, say Python pipe is pipe fun. So that's how you can use this join, which again joins elements of list into a single string. Next thing that we want to look at is replace, which replaces a substring with another. So let's create a new one. I am going to comment this print, and I am going to create a text which says I love, let's say, Java. And then I'm going to create another variable, updated text, and you probably already figured out what I want to replace. What do I want to replace? I want to replace Java with Python. Now think about it, you have a book on Java and you replace everything that says Java in there with Python. It becomes Java programming to Python programming. Will that not be easy? But again, Python is much more easier. That's why I love Python. Now let's print that out, updated text. So if I run this, I have I love Python instead of I love Java, because Java got replaced by Python. Similarly, the last one that we're going to talk about is strip, which removes white spaces or specified characters from the beginning and end of the string. So for example, let's say I have a messy string here, which is space, 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 hello, comma, space, world, and I have space, 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 space at the end of it. Now I can say cleaned text equal to, I can give that messy dot strip. Now by default, it will remove all the spaces from front and back. So I'm going to say, print me the clean text. Run it, and there you go. I have hello world. I'm going to comment this just so that we just see hello world here. So all the space has been removed. If I just, what if I just print messy first just to see the difference? You see, there you go. This is my messy string which has space in front and back, and this is my cleaned up string which has no spaces in front and back. So that's how strip works. Next thing that we want to talk about is regular expressions for pattern matching. Now, this is very interesting and is used quite a lot. If you have done any bit of programming, you know how important regular expressions are. Now, what are regular expressions? It's a way to search, match, and manipulate text based on patterns. For example, email is a particular pattern where you look for text in the start, at the rate sign, and a domain name dot something com or AI or org or anything at the end. So it's a particular pattern that you're following. So it's helpful to search and match and also manipulate text based on particular patterns. That's where we use regular expression. The thing that we use, there's a module available. It's called the RE module or regular expression module. We import the regular expression module for regex operations. The way to do it is something similar to math that we've done before, where you can just say import RE. There you go. That's our module that we would want to import when we are using regular expressions. Some of the common functions that are available in the regular expressions are, one is re.search, where you give the pattern and the string. So what it does is it searches for a pattern in that particular string. So if you have like a big huge document full of string and you want to find emails in that particular string, so you can give a pattern saying that I'm looking for email style pattern inside that string and pass it there, and it will give you. Another thing that we have is find all, which actually finds all the patterns, all the occurrences of a particular pattern. In the first case, it will get you the first one, but find all will list you all the occurrences of that particular pattern. Next, we have re.sub, which is substitute, which means it replaces occurrences of a particular pattern. So let's try out some examples where we can use the regular expressions. So I'm going to go ahead and create a new file. I'm going to call it day5 underscore regex.py. Here first, as I mentioned, we need to import RE, which is our module for regular expressions. Now I want to create a string here which says contact me at 123 456 7890. That's my phone number. So what I'm going to do is I'm trying to find all the digits in a particular string. To do that, I can just say digits equal to re dot, as I mentioned, find all is the function. And here I'm going to say the regex that I'm trying to look for. This is the pattern slash d, which is digits more than once. If it appears, just display me those. And inside my text, so print digits. So what it will do is it will try to look for digits, either one or more than one, because I've said plus here. So 1, 2, 3, let's say 4, 5, 6, and then 7, 8, 9, 0, because there's dash in between them. That's why it will separate them out. So I am going to go here, clear this out, and I'll say Python day5 underscore regex. And there you go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that found me all the digits that are there, 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0. Those are the digits I found. Now, what if I want to replace all the digits with X for security purposes? So I can say updated underscore text equal to RE, as I mentioned, sub, which substitutes the numbers. Now I'll have to first give the pattern. I can say R, wherever there's a digit. Now in this case, I'm not going to say plus, because if I say plus, it will replace 1, 2, 3 as a single X, but I want every single digit. So 1 is one digit, 2 is one digit, 3 is one digit. That's what I want to do. So I'm not giving the plus sign. So, and then I'll say that I want to replace with X. And what is my text? This is the text that I want to do it on. And I'm going to say print updated text. So you can probably see what is the use case for this. To hide for privacy reasons, you want to hide your email or phone numbers or anything that you have in the text. I run it. You see, contact me at xxx-xxx-xxxx. At least I know it's in the right format of a telephone number, and it's been replaced by X wherever there is a digit in here. So try to play around with different functions like these, all the different patterns that are available, and let me know if you are able to do something. Next, let's jump into our hands-on exercise. First, we will create a text cleaner. The objective here is to write a program that removes unwanted characters, example, punctuation, extra spaces from a particular string. So what we'll do is we'll take a string as input from the user, and then we'll remove the punctuation, extra spaces, and convert the text to all lowercase. So let's start with the project of our exercise 1 for day 5. I'm going to save it as exercise1.py, and here I would need, of course, regular expressions to do the substitutions, and I'm going to create a function called as clean the text and whatever text is provided here. Now first, as I mentioned, I want to remove punctuation. For that, I will first say from the text, I want to create a new variable text, and I want to substitute. Now in this case, I'll use R. Now for punctuations, I will use the square bracket, and I'll use the or here and say dash w dash s, so spaces. And so in here, if you see this, it says returns the string obtained by replacing the leftmost non-overlapping occurrences of the pattern in a string, the replacement repl. So that's what this does. So I am going to go ahead and say replace those with an empty string, and for operations, this is the text that I want to operate on. So it removes all the punctuations from our text that is there. Next, I want to remove extra spaces. Now for removing spaces, I'm going to say text equal to, wherever there is space, join text dot split. So this will split my entire text, remove all the spaces, and then join them with spaces just to clean it up. And finally, I will say convert to lowercase. So this will return my text that I've created, call the lower function. That is a built-in function that converts the text into lower, and that's what will be returned. Now let's, instead of asking user, let's create a input text here, but you can ask the user for a text too. You already know how to do it. Give some space, hello world, and then I'll put some exclamation marks here. Welcome to Python, comma, programming, dot, 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 space, some more spaces, and I'll say clean text or cleaned text equal to, call the function clean text, and to it pass this input text, and then I'll say print cleaned text is cleaned text. So print this out. So let's run this, and let's hope that it shows me hello world, welcome to Python programming, all in lowercase and without any punctuations and spaces. So I am going to run this. Clear. The name of the file is exercise1. So I say Python exercise1.py, and there you go. Hello world, welcome to Python programming. So it got me the entire thing, all lowercase, and cleaned up the entire text for me. Perfect. So next thing that I want to do is exercise 2, which is check if a string is a palindrome. And a palindrome is a word, a phrase, or sequence that reads the same backward as well as forward. For example, madam, M-A-D-A-M, which reads same from front or back. So that's a palindrome. So, or another example that I can give you is, if it's a, let's say a sentence says a man, a plan, a canal, Panama. That is actually a palindrome because the other way is also reach the same thing: a man, a plan, a canal, a Panama. So let's go ahead and create a new file for this. I'll call it exercise. Instead of 1, I'll call it 2. And here I'm going to check first is, so this function is going to check is palindrome, and it needs an input parameter as a text. And here first I'm going to remove all the non-alphanumeric characters and convert to lowercase. To do it in one single line, you can do something like this: dot join character dot lower for character in the text that is passed if character dot is alphanumerical. So this goes through the entire text and then converts them, removes all the non-alphanumeric characters and converts everything to lowercase. Next thing I'll do is return text equal to text colon colon -1. What this does is this checks if the text is equal to its reverse, and if it is, then it's going to say true. If it's not, it's going to say false. So this, by saying this text colon colon -11, is going to reverse the text and check if both of them look exactly same. So even if it's like madam versus a man, a plan, canal, Panama, it will remove all the commas and remove the spaces and make sure that it's exactly the same strings front or back. So that's what it does. So now let's create input underscore text here. I'm going to ask the user to enter in this particular case, so we can try a bunch of different ones. The string if is palindrome, whatever my input text is that user provided, I am going to say print. I need to display that, so I am going to use this, put those under quotes and pass the input text. I'm going to say is a palindrome, and if not, I will use else. You got it right. Else I'll say print is not a palindrome. So let's try it out. Go ahead, clear everything, and say Python exercise2.py. So first one, let's keep it simple. Madam is a palindrome. I'll say Madden. Oh, sorry. Python exercise2 MADAN is not a palindrome because it doesn't read the same. Next one is, as I mentioned, a man. Oops, sorry. Run this function first. A man, a plan, a canal. I will make sure that I don't do any Panama. So if you see a man, a plan, a canal, PANAMA. So run it. Is a palindrome, because if you read it out, if you remove all the commas and spaces, and if you read it out, it's exactly the same read from front versus its reverse. So there you go. So we have our code here, which checks if a string is palindrome. If you were able to do both these exercises, that's good. If not, if you had any issues or problems, let me know in my messages and I'll check them and get back to you. And for some additional practice, you can try to write a program to count the number of vowels in a string. Try that out. Next, you can create a program to find and replace all email addresses in a text using regex. So, and for regex help, you can always go online, just search for regex expressions or regex creators, and you'll find some regex creators online where you can test it out and then use it in your code. And today we have one more, which is write a program to reverse the word in a sentence, not the letters, the words in a sentence. So try that out and let me know if you have any problems. So just to summarize, on day 5, we did some practical experience in working with string, mastering common methods, and learning to use regular expressions for text processing tasks. Now, these skills are essential for natural language processing (NLP), and that's why we went through these, and also for data cleaning in AI applications. If you had any issues or problems, let me know right now, because these are the basic foundational things for functions that we need to do for NLP and data cleaning in AI. Welcome to day 6. Today we are going to cover file handling. Now, specifically, file handling in Python is much more easier with all the functions that are available. We will start with reading and writing text files. First thing here, we want to look at opening files. Now, to open files, you can use the built-in open function to open a particular file. Now, when you open a file, usually you have to specify read, write, or you want to append something, or read and write, both modes that you have to particularly specify here. So we have different modes. The default mode is read, which you can also specify by the letter R. We have the write mode, which overrides the file if it already exists, which you can use the W keyword. We have append, which adds data to the end of the file. You can use A for that. And finally, we have read and write, which is R plus, which you can use if you want to read and write a particular file after you open it. So this was about opening files. How about reading files? So when you want to read a file, you can use the dot read to read the entire file content. But if you want to just read one line at a time, you can use the dot read line function. And what if you want to read all the lines? So you can use read lines. What it does is it gets all the lines and gives you a list of the entire item. If you want to see an example of how this works, I'm going to create a new file here and save it inside my day 6. I'm going to call it day 6 samples. Here, I'm going to start with something called as a with statement, which we'll talk about in a little while. But to open a file, I say open, and I give the name of the file. Let's say sample.txt. That's the name of the file. Now you have to specify here, as I mentioned earlier, the different modes for opening a file is either read or write or append or read and write. So these are different operations. This is the default one. If you don't specify this, it will use read. And I'm going to say read this as a file. So this will be my file that has all the contents of whatever I've opened here. And then I'll say content. I want to get that content. I'm going to say file dot read. So once I open the file as a file, I am going to take that file and then read it. Now this will read, as I mentioned, the entire file content into one single variable, which is content. And you can just say print content here. Now, what if you want to read only one line? You can just say read line. Now, the thing with read line is it's always used with a loop, where you loop through each line at a time and do process the content. But sometimes you just want to read the first line or one line, then you just use read line. Also, we have read lines, which will give a list. So this content will be a list of each and every line that this file has. So that's how you use open and read. Now let's go ahead and look at writing to files. Now to write to files, you use the function .write, which writes a string to a particular file. You can use write lines to write multiple lines from a list. So if you have a list of items and you want to write them to a particular file, you can just say write lines and it will take each and every item and write to a particular file. So the way to do this is you specify that you want to write to a file, and here instead of this, I'm going to comment this out. I'm going to say file that I have, object that I have. I'm going to write to it, and I want to write something like hello world. Okay, so that's what I want to write. Now if I want to write multiple lines, I can just say file, as I mentioned, dot write lines, and here I give a array of items. I'm going to say Alice, Bob, and Cherry, something like that. So this will take this list of items and write these in different lines inside a particular file. That's how write lines work and write works. So next, let's look at using with statements for file management. We already used it, but how does it work? And first of all, what is the with statement? Now, this ensures that files that you've opened are properly closed after the operations, even if an exception occurs. So, make sure that something is not going right and your program crashes, it will make sure that the file is still properly saved and secured, and you don't lose the content that you're working on. So that's what with statement does. The syntax for this is, I can just continue here and specify with. So as I mentioned here, with, and then you say open a particular file, which we have done already here. So as a particular file, so what this does is, at the end of it here, file is automatically closed. So this will make sure that the file that you opened, in this case a sample.txt file, is automatically closed, and you don't have to worry about closing it. In some programming languages, you'll probably have to close an open file, but in Python, if you use with, you don't have to close it specifically. So what are the advantages of using this particular with? As I mentioned, it ensures files are properly closed after operations, even if an exception occurs. The advantages includes, it simplifies the code, making it much easier. You don't have to remember to close the file, and also it reduces the risk of file corruption. So if you have a file open and operations are going on and things are happening, it might corrupt a particular file. So making sure that every time, no matter what programming language you use, you open a file, you have to close it. So that's what it make sure of. So that's why always using with is a very good best practice. Next, we're going to look at basic exception handling for file operations. Why use exception handling? What it does is, it prevents the program from crashing due to file related errors. Example, file not found, or there is a file issue, file is corrupt, or file has some problems, or it is not readable by that particular user. So there can be a bunch of different problems, may it access related, or maybe the file is not there. So having exception handling helps you make sure that your code doesn't crash and moves to the next line, or exits gracefully depending on what you're trying to do. So that's why exception handling is important. We use something called as the try except blocks. So let's jump into how to use the try except block. So I am going to quickly write some code here. I said try, this is how you start with, and then inside here you start with and open the file. So for example, sample.txt file I want to open. I want to open it in read mode as file, and I'm going to take the content from that file and say file dot read. I'm going to comment all these things here because I think it got messed up. So I am going to say comment or just get rid of it. And here file dot read. Now if this doesn't work out, if it breaks, I have to do exception handling for except file not found error. If the file was not found, because there is no file called as sample.txt, so it will crash in our case. So that's why exception handling here helps. And I'm going to give an error to my user saying file not found, something like this. So what happens in this case is, I'm trying to open this file, but if the file doesn't exist, I don't want this application to crash. I want to just print a message saying file not found. So some of the common file not or common file handling exceptions include, we have file not found error, which we just saw, where the file does not exist. We sometimes look for permission error, where the user doesn't have sufficient permissions to access the particular file. And then finally, also the IO error, where general input output errors, where you look for all kinds of editing permissions or input output errors. So that's what we look in IO error. So now that we understand how to open the file, read a file, go through a file, do exception handling, let's jump into some hands-on exercise. Our first exercise today is to count the words and lines in a particular file. So the objective here is to write a program to read a text file and output the number of words and lines. So the instructions that I would probably follow here will be open the file in read mode first, because we don't have to write something, we just have to count the lines. Then we count the number of lines using a loop. And then finally, we'll count the number of words in each line using the split function that you used before. So let's go ahead and write some code. Now open a new file. I'm going to save it as day 6 exercise 1.py. Now here, first, let's write the function. So I'm going to say, I always start with the function. The reason is it's always helpful to reuse this somewhere else if I need this in future. So I'm going to say count words and lines, and I'll pass it a file name. Now first thing is start always with the try except block. So I'm going to say try, and I'm going to say with open the file. I'll use that file name that is passed to me, and I'm going to say this is in read only mode, and take that and assign it to this variable file. So my file is available now. Next, I'm going to say lines equal to file dot read lines. This is how I can read all the lines into a list of items. So lines will be a list of items with all the lines in there. Next, I'm going to say line underscore count. So I'm going to count the lines, which is using the length function len, and then say how many lines are there in this particular, or how many list of items are there inside this. So that's what I'll get here. Next, I'm going to say word underscore count. So I need to get the word count. So this is sum of length of line dot split. I'm going to explain you in a second of what I'm doing here for line in lines. So what I'm going to do here is I am writing a for loop where I'm going through each and every line inside the lines list. So I'm going each and every item inside this lines, and I'm saying split that into based on spaces. So that will give me words. So this will give me the number of words that are there. And then finally, I'm summing all of them up to get the total word count. So next step is I'll say print f, or f outside, number of lines equal to line count. Use something similar, but this time I'll say number of words in there is word count. Now next, I will get outside in of the try and write the except file not found. So this file I have not created yet. So this should, if I run this statement or run this code, it will just say file not found. So I'm going to say print f file, specify what the file name is, not found. So that's the error that I'll give the user. So let's write here outside some code to run this function. So I'm going to say count words and lines, and I'm going to give a file called as sample.txt. If you look at my, let's say, open dot this particular folder where we have day 6 code, but there's no sample.txt file here. So if I run this code, let's go ahead here and then clear it out. Say Python day 6 exercise 1 py file sample.txt not found, because there is no file inside here that's called sample.txt. So let's create one. So create one, save it as sample.txt, and here I'm going to say hello world, how are you, what is the plan for today, are you working on AI technologies. So just some basic 4 lines of text. Now let's go ahead and run this, and it says number of lines is 4. So 1 2 3 4. Number of words is 17. So if you count these words 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So it did count the words and the lines and displayed out to you. So this is what we are expecting for our first exercise. So I hope you were able to follow along. If not, if you had any issues, let me know. Now let's look at our second exercise. Our second exercise is to write and read a list of items. So the objective here is to create a program that writes a list of items to a particular file, then reads it back and displays the content. So what we will be doing first is we'll write a list of items to a file, each on a new line, and then we'll read the file and display it content. So which means we'll have to write a couple of functions, one to write and one to read. So let's start with our exercise 2. Create a new file, save it as day 6 exercise 2.py. Here, as I mentioned, the first step is to write items to file, and then I want to know what is the file name where I want to save this or where I want to write, and what are the items that you want to write. Inside this function, I'm going to first say, I'm not using the try except, but it's a good practice to always use that. I'm just going to keep it simple and straightforward for now. Let's say file name write as file, and then I'm going to say for item, for each and every item that is passed in the items list that we have, I am going to say file dot write, not write lines. But we can use directly write lines and use this, but I'm just going to show you how to use this for loop. Item plus, I'm going to also do new line here, so slash n. So based on whatever we get, I want to write that line and then go to a new line. Next, our next function that I mentioned was to read items from file and then pass the file name. So as you saw here, I didn't use the try except because I have full access to this OS and I don't have to worry about any of the exceptions. But sometimes you might have to, because what if you don't have the permission or access? But for read, I don't know if the file is available or not. So that's why I am going to use the try except. Open file name, comma, I want to do it in the read mode as file, so I get the contents of this file inside this file. Say items equal to file dot, I'm going to read all the lines, I'm not going to do one at a time but all of them together, and then I'll print saying items in the file are for item in items. So since I have all the items in there, I'm gonna loop through each one of them and print each item at a time. But I'll also strip those items if there's any spaces or anything, so I don't have to worry about that. And then finally, my except block here, which is only for file not found. I'm not looking for any other errors because I know that I have permissions, I have no input IO error operations. But again, when production code, you should try to catch all the exceptions that are there. File name, make sure no typos there, not found. Okay, that's perfect. Now next thing is to test the functions. So I'm going to say, I'm going to create an items array, call it apple, banana, or call it fruits. Then we have cherry and let's say dates. Just for consistency, make sure everything is capital here. And then first I'll write to a file. So I'm going to say write items to a file. Now this doesn't exist. I'm going to call it fruits.txt. This file doesn't exist. If you see here, there is no fruits.txt. I'm going to clear it out. And to this, so write to file needs two parameters. One is the name of the file and the other one is the items, which is my fruits. So that's once I've given that. Now next I want to read items from the file, and the file name that is same as this. There you go, perfect. If I change this name to, let's say, items.txt, let's see what happens, just for the fun of it. Now go ahead, again, ls, there's no file that says fruits.txt right now. There's no items.txt either. So now when I run this, Python going to call it, what is the name, day 6 underscore exercise 2.py. And it says file items not found. So it was not able to find that. Why? Because the name is fruits. But if I ls here, you'll see I already have the fruits.txt file. So that file got created, and I'm very sure if I open it, it will show me the fruits that I've added. But I am going to not run it that way. I'm going to use my code. And if you see items in the file, apple, banana, cherry, and dates. And that's the fruits file here. I can always go ahead, open dot, and open this file and see it has these 4 items that I've added. So you can add more items. So think of it as like if you want to build something where you're caching items to your local direct your user's local computer, you can call a API, get the weather for 100 countries or 100 cities, save it locally, and show that throughout the day. So then the user doesn't have to call a particular API again and again for something. So that's where it can be helpful. Now, in this particular case, think of it as like if you're making an application where you are displaying different types of recipes. Now, you don't want to download the recipes from the website again and again. So you do it once, save it on the local machine, and then let the user see it. So I hope you were able to work with this project and follow along. If not, let me know. But there's some additional work that I can give you for practice. First, try to write a program to copy the contents of one file to another. So you create a file, add some data there, read the contents of that particular file. First, open the file, read the contents, and then write to another file. Next, create a program that counts the number of occurrences of a specific word in a text, more like a search engine. Create a file where you add a bunch of text inside it and then search for a particular text and see how many times it occurred. Next, write a program to log messages with timestamps into a file. So this is a little bit different where we have not looked at how to write timestamps, but you can use some Python built-in functions, and I'll let you do the research of how to get the current time. So what you're going to do is ask users some input, and then when the user enters something on the command prompt, save them as a log message inside a particular file and also put the time when the user entered that, and then run a while loop through it and constantly log these messages. So to recap, today we learned the essential file handling techniques in Python, including reading and writing files, managing files with using with statements, and handling exceptions gracefully. These skills are vital for data processing tasks in the AI and beyond. So we'll probably be using this quite a lot. Let me know if you have any questions or any problems, and I'll get back to you. Day 7, Pythonic code and project work. Today, we're going to cover different topics, including writing clean Pythonic code. Now, what is Pythonic code? Pythonic code adheres to the best practices and idiomatic expressions in Python. It focuses on simplicity, readability, and leveraging Python's built in features. So, when you're writing code, you have to make sure that you write something where you have to ask yourself, will I understand what I'm writing if I come back after a year? So that this helps with sharing the code with your peers, with other friends, with online, anyone. So if you can understand your code after a year, I feel like anybody can understand it. But again, focus on simplicity, readability, and leveraging Python's built-in features. Some of the best practices that we follow are use of descriptive variable names. As you've seen that we've done, every time you create a variable, make it very descriptive. No matter how long it is or how stupid it sounds like, but it's always good to use descriptive variable names. Write modular codes with function and classes. As we've practiced, every time we try to implement some functionality, we start with a function. We write a function, we try to make it modular and make sure that it's more readable. We follow PEP 8 style guidelines. Now, this is a Python related guidelines which you can look it up, but what it says is all about writing code that is very simple, that is easy to read, and using most of the Python's built-in features. Avoid redundancy. Leverage Python's powerful built-ins. So make sure that if you're writing something over and over again, try to use functions, and also remember that Python has a bunch of built-in functions available. So if you're trying to write something, for example, getting time or trying to split something, split a particular string into different characters, this functions that are available by Python, use those. Don't rewrite all these functionalities. Let's look at list comprehensions. So, what are list comprehensions? It's a concise way to create lists using a single line of code. What do I mean by that? Let's look at the syntax and some examples. So, I'm going to start with an empty file, save it in our day 7. I'm going to call it day 7 underscore samples. And inside here, let's look at the syntax for list comprehensions. So you write your expression, and we have used it a couple of times before. And for each and every item in the iterable, use if condition. So if condition is satisfied for item in iterable, then the expression follows along. Now this is a little bit difficult to understand. So let's look at some examples. So first, let's create a list of squares. To do that, I can say squares equal to x square root of 2 for x in range of 10. So what this will do is it will give me squares for each and every item from starting from 0 to 9, because range goes from 0 to 9. So x square of 2, what it does is it will go to the first item. So if I print this out just to test it out, I can say squares, go to my terminal. Let me make sure I have this code, Python day 7 samples. And if you see, it took the first number in range 0, and 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, and so on. So that's what this gave you. But you wrote that in one single line as a list comprehension, then to kind of create iterable for multiple lines here. So this is something that you should probably get used to. Another thing I can do is let's filter even numbers. To do that, I am going to say evens equal to x for x in range of 10 if x mod 2 equal to 0. So what it does is it goes from each and every number in this range and checks the expression if x mod 2 equal to 0, then which means it's an even number. So I can just go ahead and print evens here. Let's run this, and you have this is the first is the squares, the second one is the even numbers. Now I can give it all the way till 100, make sure this is commented, run it, and you'll see all the even numbers from 0 to 100. Similarly, you can do odd numbers just by saying not equal to 0, and there you go, you have the odd numbers here. So this is how you can create list comprehensions where you're consolidating multiple lines into one single line. So that's how list comprehensions work. Next, let's look at lambda functions. Now, what are lambda functions? These are anonymous single expression functions defined using the lambda keyword. It's used in a lot of programming languages, or also called as anonymous functions or lambda somewhere else, but in Python it's used the lambda keyword. So these again are anonymous single expression functions defined using the lambda keyword. So let's look at some syntax and examples for lambda functions. So I'm going to go ahead here, comment this out, and in here, first, let's look at the syntax. The way it goes is you say lambda, and then give your arguments. So it's like giving a function, but you don't have to give the name of this particular function. That's what's called anonymous. You just give the arguments and the expression. So for example, if I'm writing a function, I'm going to say the function name, and then give the arguments here, and then my expression or my function code inside here. But think of it as it doesn't have a name, just the arguments and the expressions next to it. So let's look at some examples. I'm going to say add lambda x and y. These are my two arguments, and I'm going to say x plus y. Usually you would create a function and then put this inside the curly brackets, and these are the arguments. But using lambda, you can put everything in one single line. And I can say print add and give the arguments 3 comma 5. So it looks like as you can see, it looks like a function. And what does it output? Let's go ahead and see if it works. 8. 3 plus 5, 8. It passes these values as 3 and 5 here and runs this expression here and gives the output to here. So it's inline functions, anonymous functions, whatever you want to call it. That's what lambda is. Let's next look at some of the very common functions that we'll be using quite a lot. So we have map, filter, and reduce. First, map is applies a function to each item in an iterable. So it keeps on looping through iterable item and applies the function to it. What do I mean by that? Let's look at an example. So I'm going to go here. I'm going to go to the top of this and create a list of items called as numbers 1, 2, 3, and 4. So this is my list of items. And next, I am going to say squares equal to map lambda. So I'm creating a function here, anonymous function, and I'm saying x times 2 comma numbers. So what I'm doing is I am taking this list of items and I'm saying that I want to run this expression on this particular list of items. I'm mapping it to it. So that's how maps work. So this is the actual function, and this is the argument that is passed as x, each item at a time, and it will square the items and give it to me. I can just say print list the squares. If I save it, hope all the print statements are not, and run it, I have 1, 4, 9, and 16. 1, 4, 9, and 16. 1 square, 2 square, 3 square, 4 square. It took each and every number, squared them, and then I see the list output right here. Next that we want to look at is filter. Filter, it reduces or filters items based on a condition. Filter items. Next, let's look at the filter function. It filters items based on a condition. So let's look at an example here. I'm going to comment this out. And here, based on our previous even function, I'm going to say even list equal to filter. And here I'm going to say lambda x, lambda x is the argument, x mod 2 equal to 0. Write it properly, follow the Pythonic coding structure, and pass numbers which I have right here. So I'm going to take this here and put it here. So what it does is it goes through each and every item here and mod that and check if that item is an even number or not, and that is assigned to even list. And I can say print list of evens. When I run this, I think even list. So let's fix this. I have 2 and 4. So out of these, the even numbers are 2 and 4. And that's what filter does. It filters through an item and goes through an array, filters based on the associated lambda that we have provided here, and gives me a list of even numbers. Next, we have reduce. It's from functools, and it reduces an iterable to a single value. So it takes, like, you have an iterable item, it will reduce it to a single number. So what I can do is to use reduce. First, I'll have to, let's keep sure numbers is there. I am to get the module func tools import. From there I want to import the reduce function. I have my numbers here. I'm going to say product of all these numbers. So if multiplication of all these numbers, I can say reduce I user lambda give x comma y, because there will be two numbers that I want to multiply, x times y for a list which is numbers. So what it does is it takes one number at a time, one and two, or two numbers at a time, pass as arguments here and multiply them, and whatever solution comes out, it will take the next number, do the multiplication, take the next number, do the multiplication, and finally print the product as one single number instead of a list of items. So if I go ahead and run it, I will get the output 24, because 1 times 2 times 3 times 4 is 24. Next, let's look at Python's OS and sys modules. So first, OS module. This provides functions to interact with the operating system itself. Some of the common functions include how to create a new directory, how to remove a particular file, and we can see those examples here. I can just quickly run through it. I am going to go all the way to the top, remove everything, and first, to use the OS module, you have to say import OS. Then I can say print os dot get cwd. This will get you the current working directory that you are in. So it's a function. Also, you can say os.mk directory. You can create a directory inside there. Let's call it test underscore directory. This will create a new directory called as test directory. You can say os.remove, and you can delete a particular file. Let's see, what do we have in this particular folder? ls. I don't have any file, so let's create a file. I am going to call this file file.txt and save it there and say test file. Let's make sure it's there. There you go. We have the file.txt file, and that file I am going to remove using this. So let's run it now. I'm going to say Python, and if you see, there's no folders inside this too. Day 7, and let's look at it. So day 7 has a test directory over here, but it doesn't have any files. So what happened to that? It got removed. It got deleted by this os.remove function. And as you can see here, it has the new directory that was created by this mk directory command or function. And then this is also, if you see here, I said get cwd, and as you saw here, it gave me the path users Vivin Rana desktop AI bootcamp week 1 day 7. So I'm in this particular folder. So it gave me the current working directory. So this is pretty useful. Next, we have the sys module. This provides access to system specific parameters and functions, like you can get some command line arguments, Python version that you have. So all those options you can get using this system specific sys module. Let's run that and check it out. I am going to remove this. I don't need this anymore. So I'm going to say import sys, that's the module. And then I can say print sys dot argv. This will give me the command line arguments. Print sys dot version. Now since I'm using Python, it will give me Python version here. I can run this. Let's clear it out first, and then say Python day 7 dot samples, and you see here day 7 dot this is the arguments that was passed, which is the name of the file here, and then it gave me the version. I'm running Python 3.12.7 as per this, and it gives me some details about that depending on what it gives me when I write Python dash dash version Python 3.12 plus a little bit more details here. So that's what this sys module does. So now that we understand both OS and sys module, there's a lot of different things that we learned to this day. So let's go ahead and put them to use by creating a hands-on project. And this hands-on project will be a command line task manager. We have only one this time, but this is quite a detailed project that we're going to work on. The objective here is to build a command line application to manage tasks using Pythonic practices. So some of the features that we'll be adding to this particular task manager is you can add tasks, you can view all the tasks that are there, you can mark tasks as complete, and you can also delete tasks. So to go step by step, first step is always to plan the structure. We want to store tasks in a dictionary or a text file with unique IDs. And each task has a title and a status which will either be incomplete or complete. So let's go ahead and create a new file. I'm going to close all these other projects. Here, let's save it as, I'm going to just call it day 7 task manager.py. So now that we have named it, as I mentioned, some things that we had need first is the OS module. Import OS. I am going to create a file where I'm going to store all the tasks. So I'm going to call it, let's comment it out to file to store tasks. And this file, I can give a file name. Let's call it tasks.txt. And then let's load all these tasks from the file. So the reason I'm importing OS is, I'm going to tell you in 1 second, load underscore task. So this, I always like to write comments, load task from file, and inside this function I am going to say create a dictionary task equal to empty tasks. Now I'm going to check if OS, the module that we imported, dot path dot exists. So it also helps you to check if a particular task exists. File name. So does this file exist is what I'm trying to do here. If it does exist, I'm going to say with open file name, comma, readable file as file. So we already saw how to open files. This is what we've done here. And then for that, I'll say for each line in file. Now this file is called task.txt. So I would assume that each line is a task. So that's what I'm trying to get here. I'm going to say task underscore id, comma, title, comma, status. These are the three things that we'll save in a task. And these, since they're saved in the file, I'm going to say for each line, strip it, and I'm going to use a special character. I'm going to use pipe. So each so task ID, title, and status will be separated by a pipe. That's how I create my database here. And then I'll say task int of task ID. I'm converting the task ID into int and getting an index, and I'm saying that inside this, the title of this particular task is this, and the status is whatever status we got. So we have this task ID, title, and status. So I'm creating task inside this empty dictionary here, where I'm saying, let's say the first task in there has a title of title, whatever we got from the file. Status is status. So I'm creating my database here. I'm loading all the tasks inside this dictionary here. Once I have done that, I'm going to go here and say return task. If the file doesn't exist, which means there's no task, it will return back an empty dictionary, which is what's going to happen the first time when I run it, because there is no task.txt file right now, as you can see right here. I'm going to delete this folder which we have created in our previous project. So move to trash. Yep. So next is save tasks to file. So as and when user creates a task, I want to save those tasks into into that task file. I'm going to say save underscore tasks with open. So I'll take the file name of the task. I'll say write mode as file. I want to save for task underscore id comma task in tasks dot items. From in this particular task, whatever tasks are there, for each one of them I want to save them to file. So to do that, I'll say file dot write f, and as I mentioned, how do we write this? I'll say task underscore id space pipe space the formatting that we've mentioned, task of title space pipe space, and finally task of uh, status. That's my third one. Let me see, everything is closed properly, slash n. I'm also giving a new line character, so it adds one task and goes to the next line and keeps on writing for each and every task that is available. It'll save to the file. So that looks good. Our next thing that we want to do is, so this will save the task. Now what if I want to add new task? Add a new task. I'm going to create another function called as add task and pass the task object. I'll say title equal to input. I'm going to ask the user enter task title. So user will enter a task title for this. Task underscore id equal to max of tasks dot keys comma default equal to 0 plus 1. So what I'm doing here is I am taking the task and looking at the keys and getting the max value from the task. So I'm getting the max ID that is available right now. If doesn't exist, then I'll use the default 0, which means my first ID will be 1. If not, it will, let's say if there's 4 tasks and 1, 2, 3, 4 is the task IDs. So it will get 4 here, 4 plus 1, 5. That will be the new task ID. Next, I'm going to say tasks. For that particular task ID, I will have to give the title, which in this case is whatever user entered, which comes from title here, and then status. Since it's just created, I would think of it as incomplete. There you go. So I am going to, at the end of it, I'm going to say f task, whatever the task is, title that user entered. Let's fix this, task title added. So we give this message to the user. Next is, let's write a function to view all the tasks. So def view task, and inside that I'll pass that task checked, and here I'm going to say if not task. What I'm doing here is I'm checking if the task values are there or not. If not, if there's nothing in there, if the array is empty, if the dictionary is empty, I'm going to say if no tasks available. Else, there are some things inside this dictionary. What do? I'm going to say for task underscore id. I'm going to iterate through all of them and get the task id and task in task dot items. So I'm going to go through each and every item inside task and get the task id and task and print that to our user. I'll say, let's say bracket, and inside this I'll say task underscore id. So we'll give that id inside a bracket and say task whatever the title is, and task, I'll have to provide the status. So I'll say status is this. So that's what I'm printing it out to the user if they want to view all the tasks. Now next, from whatever we have done, okay, so these are incomplete. So let's say we want to change the mark the task as complete. So this is mark task as complete from incomplete status. So I'm going to say define mark task complete function. It takes the array of task. Now first thing I'll have to do is I'll have to get the task ID for which I want to change it. So I'm going to say task ID equal to int input. I'm going to ask the user enter task ID to mark as complete. I'm going to ask the user. Now we are displaying the task ID. So I'm going to ask the user which one do you want to mark as complete that you've completed. And if first I'll check task underscore ID in task. If it exists in that task object, what I'm going to do is I'm going to say tasks task ID. I'm going to get that item, and to that status I am going to mark as complete. So if it was incomplete when it was created, now it's complete. So that's good. I'm going to say print just to display a message to the user. Task ID, whatever the title of that is, and it closes here, marked as complete. That's what I'm going to say to user, and that will be displayed to the user. Oh, wrong place. Okay, we also have else. What if the task doesn't exist? I'm just going to say print task ID not found. So they can view, you call view all task and check if the task is there or not. Next thing, the main, we forgot to delete, I guess, in this case. So we have, which mentioned we are also going to add delete. So I'm going to say delete a task. It will be something similar to this. So I'm going to just copy that up here, and I am going to say delete task, and I'm going to get the ID, enter task ID to delete. Task ID in task, I'm not going to mark this deleted underscore task equal to tasks dot, I'll just pop it depending on the task ID. There you go. So that will delete it. So then I can say task deleted, else ID not found. Perfect. Our next step is the main menu, which will display all the options for our user. So I'll call it def main, and inside my main function I'll probably first say task equal to load task, and I want to see get all the tasks as soon as the program runs. I say while true. If you remember while loops, it will keep on running until the user specifically says exit. I'm going to give the user some access. First I'll say /n, next line, task manager menu. That's my first. Next I'm going to say print. First option that I want to give user is add a task. Okay. Next option that I want to give user is view all the tasks. Next option that we want to give 3 is, we said add view mark task as complete. Mark task as complete. Next option that I want to give user is the fourth one. Let's delete a task. And next one that I want to give user, the fifth one, is to exit out of this program. Print 5, exit 1 2 3 4 5. So I have all my 5 options. Now let's get user's choice equal to input, enter your choice. So we're asking the user to enter something, and now we'll run through all those. If choice equal to 1, what do I want to do? I want to add a particular task to the tasks. Okay, perfect. Add task. Next one, else if the choice equal to, let's say, the user type 2. In this particular case, I want to view task. So I can just say view task and pass the task object to it. Next, looks like there might be a problem in the code, but let's see. As and when we run this. 3, if the user picks 3, I'm going to say mark task complete. Now for that, I'll also give task because everything happens inside there. Next option is if the user picks 4, that is to delete task. So I'm going to say delete task. Perfect. Next thing that I want to do, delete task, if the user says that they want to quit, which is choice equal to 5. Since the user is getting out of the loop, I want to save the task. So I'm going to say save the task, because if user has added something, deleted stuff, so I want to make sure that it's persist on the hard disk. So I'll say save task. I'll say print, give a goodbye message to the user. Always good to say goodbye, and break out of the while loop here. So that's what we're doing here. Also, what if user enters something else and none of these options? Oops. Else, I will say, like, what if user says 6? Then I'm gonna say invalid choice. We'll try this first. Please try again. Okay, now in Python, if you want to run the main function, you have to say name underscore underscore name equal to underscore underscore main underscore underscore. I want to run the main function. That's how you run the main function when the application starts, and that's our main over there. So looks like we have everything in place. I want to just check if we have somewhere task equal to, nope. Okay, perfect. So this looks good, but let's see if it runs properly. So first, I'm going to clear this out. ls, I have my code file there, day 7. I don't have any files. Task manager. It gave me options here. If I say 9, invalid choice, please try again, because that was our choice that doesn't exist. I want to view all the tasks. Since there's no task available, it will say no task available. Let's add a task 1. Enter task title. I'll say buy milk. Okay, so that's task buy milk added. Let's look at it if it's there. Okay, I have 1 buy milk incomplete. Let's add a couple of more of them. I'm gonna say buy eggs 1, get car wash. Okay, let's look at these tasks, and I see all the 3 tasks: buy milk, buy eggs, get car wash. So we can view the task. Let's mark something as complete. Let's say pick 3, and I say I already got done with buying eggs, and it says task buy eggs, mark it complete. Let's see if it's true. View the task, and if you see incomplete, complete, and incomplete, perfect. So that worked. I want to delete a task. Let me delete buy milk task. So I'm going to say 4, enter the task ID 1, and it gave me an error. I knew there was some problem somewhere. So this happened in the delete function. In delete task task ID, it says there is some problem here. Looks like, oh, it says this I copied from here. That makes sense, because this is not true. So this is deleted task, or deleted task and then inside that has a title. Makes sense? Perfect. Clear. I'm very sure nothing of this is saved. Let's say if no task available, of course that means I'll have to go through the entire process again. Add a task by milk, add a task by eggs, add a task get car wash. Let's view the task. I have all the three tasks here. Let's go ahead and directly delete. Let's say 4, and I want to delete by x again. And let's see now to view task. I have only two tasks, buy milk and get car wash. So only option left to test is 5, and it says goodbye. Perfect. So there you go. So we have our completed our project, which is creating a task manager, step by step task. Now you can create an API out of it or something to use it, but this is a basic command line interface task manager that we've created. If you have any questions or had any issues, let me know and I'll get back to you. And as per some additional features to add, I'll give you some tasks to add some additional features. You can add deadlines or priorities for task. Next thing you can do is export task to a JSON or CSV file. Something that we didn't test here was we saved those to our file. Did they get saved? Let's look at it. So here is my task.txt. When I pressed exit, it saved whatever was left in the task into this particular file. And next time when I run this, now it will open those tasks and show me the task. So I can always go here, clear it out. I can run that project again, and I can say view task, and you see those tasks are persisted to my hard disk in this particular folder because we have saved the task using this OS module function. So okay, that's so try to export the task to a JSON or CSV file. Give that as an option to the user, and then support command line arguments for quicker task management. So try these out and let me know how it goes. So today on day 7, we learned how to write clean Pythonic code, use advanced Python features, and build a real world project integrating your knowledge of functions, data structures, and file handling. Whatever we did in the entire week, we kind of put or tried to put everything together into one single project. The Task Manager project helped you reinforce these concepts through practical application. So if you had any questions or any problems, let me know and we can start with our week 2.